Welcome to the Complete Beginner's Python course, where our goal is to make coding easy to learn. We will teach you coding through hands-on lab exercises. We will enhance and accelerate learning through Jupyter Notebook's coding environment. Our goal throughout the course will be to visually explain you key concepts. We will also assign 3 capstone projects for each module to test out the students. Please meet our core team members that have created and designed the course. Together we have close to 45 years of practical implementation and teaching experience in various areas of information technology, software engineering, data science, and coding. We will have a total of 10 modules that are designed to help the students learn progressively. We will start from the basics and gradually move to more complex operations. By the end of these lessons, you'll be able to start coding in Python based on the foundational principles of this language. Key concepts are going to be explained visually throughout the course for our students. Jupyter Notebook will be used as a coding environment. It has easy-to-use graphical user interface. It enables interactive coding and data exploration, and also generates graphics and charts very easily. Every coding lecture in our course will be accompanied by a lab component that will have hands-on coding exercises for our students. Here are some of the companies that are looking for Python skills to fuel their day-to-day operations and critical software development needs. I look forward to having you join our course, and we promise that this course will help you build the foundational coding skills in Python that are necessary for you to be competitive in this marketplace.
Hi all, welcome to the course for Python. In this first lecture, we will learn about what Python is, followed by Python history and applications that have been developed in Python. Welcome to the first module for the course Introduction to Python. Python is the world's fastest growing and most powerful programming language. It is a very versatile and powerful general-purpose computer language. Python is an interpreted language, which means that you can get your answer as soon as you enter a line of instruction rather than typing a bunch of code. It is used to build different types of application ranging from desktop to web, mobile to big artificial intelligence, machine learning, and data science projects. Python is a high-level language as it is very close to human language. It is fast to learn because of its simple syntax that even a non-techie can get it quickly. It is used in rapid application development as developers can work on parallel modules and integrating modules into the final finished product using Python. One of the most promising benefits of Python is its standard library, and the interpreter are available free of charge. Python's official website is www.python.organization, from where you can easily download Python and its standard libraries and documentation. Let's have some words about the history of that masterpiece named Python. It was developed in the late 1980s by Guido van Rossum, and it was first released in 1991. Later, a non-profit organization, that is Python Software Foundation, held the rights of this language from version 2.1 and onwards. Python supports multiple programming paradigms from procedural to object-oriented. Some of the world's most concrete applications have been developed in Python. I would like to categorically discuss some of the more renowned applications developed using Python. Many general-purpose applications that are written in Python are Blender, BitTorrent, and Cinema 4D. Python has recently become popular in data sciences for a lot of reasons. It is quick in data processing, visualization, and natural language processing. Did you know Netflix and YouTube have also developed their recommendation systems in Python? Due to its user-friendliness, it has been used to develop the most amazing websites on the web. For example, your very own Instagram. The world's biggest online photo sharing application uses Python as its backend. 99% of the Dropbox code is written in it. Pinterest, and Reddit are some more examples of this language. Guess what? You can also develop games in Python. Battlefield 2, Civilization 4, and Disney's Toontown Online are some examples out of the many. Python is an extremely popular language and can be used to develop any type of application for any platform. Buckle up, let's get into the world of Python and start writing your very first line of code into that masterpiece. In this lecture, we will discuss why should you learn Python. Now let's see the comparison between some of the renowned computer languages and Python. Here you can see where the Python stands among all the other popular languages. This graph shows the popularity among programming languages, and here you can see that Python stands among the top 3 rated computer languages of the time. Java and C are top-ranked programming languages due to their applications in ERP, web, and system programming. While they are not used for artificial intelligence, data science, machine learning, and a bunch of other applications for which Python language is used. If we analyze Google search trends, it is easily interpretable that the world is searching Python more than Java, C, and C++. Python is gaining interest over a short period of time. You can see here the blue spikes in the graph that shows the Python is heading over the top of the graph. Many of the top companies are looking for Python developers such as Google, Facebook, Netflix, Dropbox, Intel, Cisco, and many more. Major stakeholders and companies require Python developers as their human resource to improve day-to-day operations and product analysis. Here are some of the giant platforms using the Python language for the development. NASA, Dropbox, Intel, Cisco, Chrome, and Firefox are utilizing the services of Python developers. Moving forward, there are many lucrative opportunities in becoming a Python professional, such as software engineer, Python developer, research analyst, data scientist, analyst developer. You can earn a handsome amount of salary in these roles and have a progressive career growth. Let's have a look at the salary facts. According to the Stack Overflow, the popularity of Python worldwide is growing, which means the demand for Python developers is expected to rise, and their salaries rise accordingly. According to the last year Indeed, average salary for a Python developer was more than $11,000 per year with a $5,000 bonus. Python is a great choice for everyone and easy for beginners to learn. So I hope now you have an idea about what Python language is and why you should start learning Python. In the next lecture, we will see the process of installing Python on different platforms. Hi, and welcome to Section 2 of the course. In this Section 2, we will learn how to set up Python environment on Windows, Linux, and Mac operating system. Along the way, I will show you how to run your Python script in interactive mode using Python Interactive Development Environment. At last, I will show you how to install Anaconda, an advanced Python toolbox for performing wonders. In this lecture, we will see how to install Python on the Windows operating system. So let's open your browser and head to the official download page. Now proceed to download button. You can download the Python for Windows, Linux, or Mac. At the moment, we download Python for Windows. Our installer has been downloaded successfully. Okay, so now we will launch the installer. Here it is. Our Python installer is launched. Follow the default instructions. Click on Add Python 3.8 to Path checkbox and click Next. After clicking Next button, Python installation has been started. Installation process will take a couple of minutes depending upon your system speed. And here our installation is completed. Now we will click on Finish and launch the Windows command prompt to check Python installation. In the command prompt, type the command python --version. If it shows the Python version, then congratulations, you have now Python installed to perform wonders. Now type the command Python to step into the Python interactive mode. In interactive mode, you can type command and get instant result. Like, I want the result of the following mathematical expressions. This is how you can use Windows command prompt to launch Python terminal. Now it's time to launch the Python's own integrated development environment. You can launch Python IDE from Start menu, and here is the Python IDE on my screen. You can perform any calculations you want, like 12 plus 78 times 453, enter, and Python will display the result. Now I create a variable number 1 and assign it the value 56. Again I create second variable number 2 and assign it 678. And now for the results, I print the result of both the numbers. So here is the result. What if we want the division of these two variables? So we will again write the same statement, but the operator will be of division. Here is the result. Now we will see how to create a separate script. Click on the File menu and then click New File. Now I write the same code we wrote a moment ago in our script file. Create two variables, number 1 and number 2, and store any values in these. Now print the sum. Difference, multiplication, and division of these two variables. In subsequent chapters, we will explore the concepts of variables, functions, data types, and much more. Before running the script, save it by clicking on File and then Save. Now choose the path and a valid script file name. Like in my case, I will write my script and hit Save button in the bottom of dialog window. Now run the script by clicking on Run and then Run Module, or simply press F5 key on the keyboard. And here is the result of script file in the main Python terminal. So this is it. In the next videos, we will see how to install Anaconda, a super Python toolbox. One of them is Jupyter Notebook that we will be using throughout the course for coding. In this lecture, we will see how to install Anaconda Navigator for Python on Windows. So for that, open your browser and type download Anaconda in the Google search bar. Now click the first link and it will take you to the Anaconda official page. Scroll down to this page and here you can see that Anaconda for Windows, Linux, and Mac. We will download Anaconda for Windows 64-bit and our installer is downloading. As the file size is more than 450 MB, that's why I have already downloaded the installer. So now we will begin with the installation setup. Click on Default Options and keep clicking Next button until you see the installation progress bar. So now our installation is completed. Now launch the Anaconda from Start menu. It will take some time to get ready. Now here it is, our Anaconda is ready. Here you can see bunch of built-in tools installed and you can install many other tools. You can manage all the tools at one place, and that is Anaconda Navigator. Here we are interested in Jupyter Notebook to write codes and perform complex coding tasks. So basically this is the interface of Jupyter Notebook that we will investigate as we move forward. First, we will create new file. Let's rename this file. Click on that untitled one on top of the notebook. enter a relevant name and hit rename. Now to write some code, we write code in this cell like 34 plus 23. Now we press enter. When you press enter, Jupyter will create room for new line. And if you enter shift plus enter keys, it will execute the code in that cell. So let's perform some basic operations using Python on Jupyter Notebook. Let's perform another operation. Let's create some variables and assign these variables some values. And then perform some actions on those variables. It's quite easy in Jupyter. So now we learned how to do some Python programming in Jupyter Notebook. In our next lab sessions, we will be using Jupyter Notebook for performing labs, so you will learn more about it. In this lecture, we will install Python on Mac operating system and we will write our first simple script. Before installing Python, you need to check whether Python is already installed or not. To verify, open your Mac terminal and type command python 3. Hence, this message indicates that Python is not installed on your Mac machine and asking from whether you want to install. For now, click cancel. We will download Python from browser and then we will install it. Now open your browser and go to Python official web page or type download Python in Google search. Here, click on that yellow download button to initiate Python download to your Mac operating system. Now open your download folder and run the Python installer. The installer will walk you through the fundamental steps of installation. Just click the continue button. Click agree and proceed. Now click on install button. Provide your admin username and password and click install software button. And you can see here installation has started. Now this process will take couple of minutes. We will wait till then. Here you can see the Python installed files. So click the close button to finish up installation. It's up to you whether you keep the installer or delete it. I will click move to trash. You can see the Python is appearing in applications directory. Now let's see how to launch Python from terminal and write some script. First, check the present working directory using command pwd. Present working directory is admin. We need to move to root directory. For this, type cd 2 times to move up to root directory. ls command is used to show all contents of your current directory so we can see the application folder. It means currently we are in root directory. Now step into the applications directory. So now we are in application directory. Now type python 3 -- version to check the Python version. And here it is. Now type just Python 3 to launch Python interpreter for writing any script. We will perform some basic operations and you can see the results of our scripts. So we are done with installing the Python on Mac operating system. In the next tutorial, we will see how to set up Anaconda on your machine. In this lecture, we will install Anaconda on Mac operating system. So first, download Anaconda for Mac OS. Open your browser and go to the Anaconda official page or type download Anaconda on Google search. This is the page. Scroll this page down to installer section. So here we will download the 64-bit graphical installer for Anaconda. After the download completes, go to Download directory and launch the Anaconda installer. Now follow the fundamental installation instructions till end. Here select Agree. Now here you select the Macintosh HD. So now click Continue and installation will begin. Now wait till the installation completes successfully. So now we are done with installation. Now close the installation window. Now we will launch the Jupyter Notebook. And here is the main window for the Jupyter Notebook. Now to create your new notebook for writing your scripts, click the New option and click Python. So here your new notebook is open now. You can write some basic operations using Python language. And you can click on this Run button to execute your code. So now we are done with the installation part of the Anaconda. We will be exploring the Jupyter Notebook in all our next lab sessions. In this lecture, we will see how to install Python on Linux operating system. So for that, we will open the terminal to check if Python is already installed or not. So here we will type the command Python to check if the Python is installed or not. Type the command python3 as we are going to use the updated version. So here you can see that it is already installed. Let's perform some of the basic operations in Python. Like I'm going to perform here some addition. Okay, again, we can write here 1 plus 45 divided by 56 into 89. And that is 72.517. So what if it is not installed in your operating system? So don't worry about that. I will write here the commands to install Python on Ubuntu. First, we will update the software repository of your operating system by typing this command sudo apt update. As my system is already updated, so I am not going to execute this command. After the package is being updated successfully, you need to write this command to install the Python. So after executing this command, the Python 3 will be installed successfully on your Ubuntu operating system. Now to install the Python ideally, here we can see that it is not installed. So now we are going to type here commands for installing the IDLE, that is Integrated Development Learning Environment for Python. So right here sudo apt install IDLE 3. Give it your user password and then proceed. It is asking for the disk space. Type in Y and enter. So it is saying that update the software repository. So here you can see that it is not installed. So now we are going to update the software packages by writing the command sudo apt update. So now the software packages are updated. We will install Python IDLE 3. So now here it is, we are done with installing the IDLE 3. This is the main window for IDLE 3, that is also called Python shell. Here we will perform some of the basic operations again to check if it is working. 34 plus 2, that is 36. And I will be explaining this in the later sections. So once the IDLE is installed, now we will see rest of the working is in other sections of our course, in the next sections of our course. You should watch that Windows lecture to see how to run and save your first code in Python terminal in Python IDLE. In this section, we will learn about basic syntax of Python language. We will also discuss about variables, data types, and comments of Python. The objective of this lesson is to get familiar with the syntax of Python. There are two methods that can be used to execute your code: interactive mode and script mode. Interactive mode is a kind of calculator to get your results as soon as you enter the statement or expression. It is helpful if the script is extremely short and you want immediate results. On the other hand, if you need to write a long piece of code or your Python scripts span over multiple files, script mode is the way to go in such cases. In script mode, you write your code in a text file, then save it with the .py extension, which stands for Python. You can use any text editor for writing Python script. Some of the great editors are Sublime, Atom, Notepad++, etc. Python variable is a space in a computer memory to store some kind of numeric or text value. So you need to create that space in the computer memory before store and retrieve a value from the variable. In Python, a variable is declared by a valid name, and after using equal sign, you can assign any value to it. You can declare multiple variables in a single statement and assign values to each of them separated by a comma. We will cover it all in the practical sessions. Instructions that a Python interpreter can execute are called statements. For example, x equals to 1 is an assignment statement that can be written in a single line. Return, if, for, while loops, etc. are also conditional statements used in all programming languages and Python as well. Here are some of the statements related to the print and the assignment statement. What is an expression? It is a combination of values, variables, operators, and calls to function. The interpreter evaluates the expression and displays the result if you print it. Most of the programming languages use braces to define a block of code. However, Python uses indentation that makes the code more readable. Generally, 4 white spaces or a tab key is used for indentation. So how does it work? All statements with the same distance to the right belong to the same block of code. That is, the statements within a block line up vertically. The block ends at a line less indented or the end of the file. If a block has to be more deeply nested, it is simply indented further to the right. The enforcement of indentation in Python makes the code look neat and clean. Alright, so summarizing things up, in this lesson, you learned the theoretical concepts of syntax being used in Python. In the upcoming sessions, you will learn about variables and how to code them in Python. In this lecture, we will learn what variables are in Python. Let's have a detailed look at variables and identifiers. So what is a variable? A variable is a reserved location in a computer memory to store your values. We can store different data types, and you can create variables to store numeric, text, or logical values. Unlike other programming languages, Python automatically reserves the memory space for each type of variable you create. Here is the diagrammatic explanation of memory and variable storage. Here n1, n2 and some are the names of variable having values 345, 56.3 and 401.3 respectively. So what is an identifier? Identifier is a name given to a variable or other entities in Python such as functions, modules, classes and so on. Identifier is a valid name that is given to a variable, function or class. Variable has other properties such as value, type and scope. And in Python, there are certain rules to create names of identifiers that we will discuss next. Point to remember is that Python is a case sensitive, like two names with different cases are considered two different identifiers. For example, variable x and variable capital letter X are not the same. No special symbols are allowed as identifier names except underscore and digits. Identifier name cannot start with digits either. Rest, your identifier can start with letters and underscores followed by underscores, digits, or letters. Reserved words such as if, for, return are not allowed as identifiers. Developers use best practices for naming variables, functions, classes, like create an identifier with upper, lower, or the first letter of the identifier as upper if the identifier has a single word. Use camel case if the identifier is of two or more words. In camel case, the first letter of the first word is lowercase and the first letter of the second or third word is capitalized. Here is the list of some valid and invalid identifiers, and they will be explored in lab work during the whole course. So for now, you have developed the basic understanding of the variable. Now open your Jupyter Notebook and have some hands-on practice. I have launched my Jupyter Notebook and we are in interactive mode of Jupyter Notebook. The good thing about the Jupyter as it is an interactive and script mode at the same time. Let's learn something simple first, that is declaring a variable with a valid name, and along the way I will tell you about data types as well. Let's learn something simple first. Declare a variable called age and assign a value 23 to it using equals to the operator. Now to print it, simple type age in the next line and press the run button on the top of the screen. Here you get the output of 23. Now instead of pressing the run button every time, you can simply press Shift plus Enter keys together to execute your code. Now declare another variable name which holds value Sarah. To assign string values, use quotation. You will learn more about in the next lecture. Now print this value using the Shift plus Enter key. The Python interpreters return name. The Python interpreter returns name is not defined in the output cell. Recall Python is case sensitive, which means name and name with the capital N are two different variables. Okay, what if I use an invalid name unknowingly or by mistake in Python? So here I am typing 123 name as a variable and passing it some value. Let's print this variable too. The Python interpreter will throw an error of invalid syntax as soon as I execute my code. So I would like to reiterate my point. Follow the naming rules as discussed in the slides earlier. Alright, let's try some more examples of variable name. Type underscore number equals to 5 and print it. It shows the result with no error. You can also give descriptive names to variables such as movie name. Type a movie space name and let's assign a value to it. Next, we will print it. Now here you notice a syntax error in the result as space isn't allowed between two words of a variable. Now here we will use underscore symbol in the middle of this variable and then we will get it print. So let's copy the same value here. So now you see, it is a valid name and the result is displayed without an error. You cannot use reserved words as variable names, as they are used by Python to perform some operations, but if you change the case of a letter, you can use them, but I will not recommend such a practice as it will lead to confusions. However, let's do an example of this. Here I am typing code both correct and incorrect. Let's try this. So here, if is a reserved word when used in lowercase, so it can't be redefined by the user, but after changing it to all uppercase, it is used successfully, as you see here. So you learned what is variable and identifiers, and how to declare a valid variable in Python. In the next session, you will be introduced to the type of variables used in Python language. In the previous lesson, you learned about variables. And in this lecture, you will be introduced to the types of the variable. So let's begin. In Python, we have 4 different types of data. Let me ask you quick questions. What is your name? What is your age? Do you have friends? And what are their names? Let's assume your answers are, my name is Sarah and I am 20 years old. Yes, I have 3 friends, Shirley, Thomas and Brian. In your answers, you can easily figure out that every answer has different data types. Sarah is a string. 20 is an integer. Yes is a boolean. Name of friends are sequence data type. Now let's open up your Jupyter Notebook and look at an example code. So let me show you how to work with different data types in Python. Declare a variable called age and assign a value 23 to it. As 23 is a numeric value, this variable is of integer data type. Now declare another variable name which holds value Sarah. Since it is a string, you have enclosed the value in single or double quotes. That is the identification of string value. We will learn more about strings in later sessions. Now print both values using function print. So we print age and we print name. The print is a built-in Python functions to display variables or literals. Now execute your code using the Shift plus Enter key. Now these results are familiar to you. Now I am declaring another variable and passing it value 5, but this time enclosing it in a single quotation. Now add this number with itself. Run your code and here you can see that instead of adding 5 with 5 and giving 10 as output, it is repeating the variable, or you can say concatenating it with itself, as 5 is no more a numeric value but a string. So now you get the idea of data types as well. Let's declare another variable, type salary as the variable name and pass 1523.56 to it. This is an example of floating point data, as it carries decimal point in number value. Now print the value. If you want to know the variable type, you can use method type. Here, instead of printing the value of salary, I am using a type method to show you how it works. The output screen shows float in the result. Let's pass email address in a quotation which contains some special character too. There is a typo in the printing variable. Let me type it again as email underscore ID, and here you can see that the variable value gets printed. Let's learn how to declare a Boolean value. Type variable name as learning equals true, where we have assigned a true value to the learning variable. Boolean can have only true or false as values. You can also check its variable type. So here you see the type for learning variable is bool. Coming to the last point of the lesson, variables names can be reused again with the same or different data types. The earlier name has value Sarah. Now I am reassigning value to Martin. Now if I print this variable, it will show me the latest value as it gets updated. Now I am changing the variable type of variable name. I will assign it a Boolean value false. So now the result shows that the name is now a bool variable instead of a string. So Python is a super language. It decides the type of variable according to the type of value assigned to it. In the next tutorial, you will learn how to add comments to your code. In this lecture, we will see how to comment in Python. Comments are lines of text that are like remarks or annotations we use to provide some contextual information. Python ignores and never executes the comment line. In Python, we use the hash symbol to write a single line comment. Comments are very important while writing a program. They tell you what is going on in the source code and you do not have a hard time figuring it out. We can have multiple line comments that can extend up to multiple lines. One way is to use the hash at the beginning of each line, and another way of doing this is to use triple quotes. Let me show you how to add comments in Python environment. Open your Jupyter Notebook. Comments are a very important part of your code and used to explain your code. In Python, comments start with a hash symbol. Here I am typing a sentence. This is a single line comment. Now type a sentence, "Welcome to Python tutorial," in the next line inside the print method. Now run your code. The Python interpreter will ignore them while executing code. As you see here, only the sentence provided in the print method is shown in the output cell. Comments can be used not only to explain code but to stop some code statements from executing. Now copy and paste the above cell and comment out the print method and write a new print method with a new sentence, "Welcome to Skillcar." To comment out some lines of your code is particularly helpful while debugging, that is an error finding. You can also add multiple line comments in your code either by adding a hash symbol at the beginning of each sentence or by using 3 single or double quotations. Both are correct ways. Let me show you an example of it. It is a multi-line comment as it spans over multiple lines. Next, I am typing a print statement which says "Hello world." See the result, the line enclosed in 3 double quotes are ignored by the Python interpreter. You can repeat the same process with 3 single quotes as well. So in this lab, you learned how to insert single or multiple line comments in Python. Welcome to Section 4, Numbers and Maths. In the previous session, you learned about declaring and using variables of different types. This time, we will perform mathematical operations on variables by learning operators available in Python. Operators are the symbols which do some actions on values called operands to generate the single value result. Did you confuse the operands? Don't worry about that. Consider an example result equals to 12 plus 2. Here 12 and 2 are operands on which addition operator is applied, and the result, that is 14, stored in variable result using assignment operator equals. This addition operator operates on 12 and 2 and adds them together. Here are 2 examples of operators and operands. And examples on the left hand side, 3 and 7 are operands, and minus is a binary operator followed by a plus operator. On the right hand side, number 1 and number 2 are operands, and slash is a binary operator followed by equal of the operators. In general, there are 2 common operators, unary and binary. Let me show you some examples of operators and tell you about operators and the difference between unary and binary operators. Open your Jupyter Notebook. Here I am typing 6 plus 2. In Python, when you write this expression, you are asking Python to add 6 and 2 together. Notice plus here is an operator as it is operating on 6 and 2, whereas 6 and 2 are operands because they are being acted upon. Lastly, plus here is a binary operator as it acts on 2 operands. Let me run this code. In the output cell, you get the result 8. What if I type minus 2? Here minus sign is a unary operator as it is acted on single operand 2. Some operators can act as unary or binary operators depending on the expression in which they are used. Now I am typing minus 8 minus 2. This statement is a combination of the unary and binary operator. The first minus sign represents the unary operator and the later represents the binary operator. Run this code and we get minus 10 as expected. There are different types of operators available in Python. We have arithmetic operators for basic mathematical operations. Relational operators are used to compare 2 operands. We have an assignment operator which assigns the value on its right to the variable to its left. We also have membership operator. The job of this operator is to find out if an element is a member of sequence or not using in and not in. Identity operator checks if 2 variables or objects are pointing to the same memory location or not using is and is not. Each of these operators uses different symbols. For example, arithmetic operators use plus minus, multiply, modulus symbols. Relational operators use less than, greater than, and equals to symbol. And in logical operations, we use and, or, and not operators. We will talk about each of them in detail in upcoming lessons. In this lesson, we will learn about the mathematical operators in Python. First, let's talk about the general ones, that is the arithmetic operators. Plus symbol is used for addition, minus symbol is used for subtraction, asterisk symbol for multiplication, slash, single slash for division, double slash for whole division, and a unary minus sign, double asterisk symbol to calculate the exponent, percent stands for modulus operation. Let's perform some arithmetic operations in Jupyter Notebook. Arithmetic operators are very easy to understand. I will show you some arithmetic operations. So to get the sum of 2 numbers, use a plus sign such as 5 plus 2 and run it. So the output cell shows you the summation result 7. 4 minus 3 is 1. Next, type 2 asterisk 9. Asterisk symbol is used for multiplication and output is 18. Coming to division, Python has two division operators, a single slash character for classic division and a double slash for floor division, which rounds down the result to the nearest whole number. The single slash will give you floating point values in the result. Type 15/2, it gives you 7.5, that is a floating point value. Whereas, if you use double slash, it gives you the whole number 7 only, which is the floor value. Then we have a modulus operator. Type 15%2. The percent is a modulus operator. Do you know the answer? It is certainly 1, because when you divide 15 by 2, the remainder that is left is 1, as 2 times 7 is 14. Next, we have exponent. Here I am typing 2 double asterisk 3, which means 2 raised to the power 3, and of course the answer is 8. Let me tell you about operator precedence. Type 6 into 8 followed by a slash. Next, open parenthesis and type 2 asterisk 2. When you run your code, you get 12.0, that is a floating point result. Now, if I remove the parenthesis, so now I get 48.0 as the answer. This is because Python follows the BODMAS rule. First, brackets are evaluated, next division followed by multiplication, addition, and in the last, subtraction. Let me try another example. So we will type here 2 plus 3 asterisk 4/2. So what do you want to be calculated? If you want 4 to be divided by 2 first and then result multiplied by 3 and finally add 2 to it, then you have right the correct expression. Let's run the code. However, if you want an addition to be performed first, then you need to enclose 2 plus 3 in parentheses and you will get a different result. Let's see the result for this as well. Alright, so Python follows operator precedence rule. I will show you the list of precedence rule at the end of the lecture. Now let's move to the relational operators. Relational or comparison operators compare two operands and they always evaluate to either true or false. For example, you want to test whether two numbers are equal or not, to find the greatest number out of two, etc. Let me show you some examples in Jupyter Notebook. And as discussed in the slides, let's perform some relational operators. Declare two integer variables, number 1 and number 2, having values 12 and 2 respectively. Now use a relational operator with a greater than symbol between the two. Type number 1 greater number 2. Run your code. As number 1 is greater than number 2, the output cell returns true. Let's reassign the same values to both variables in a new cell. To find whether a number is greater than or equals to the other one, we use greater equal symbol. So we will type number 1 greater than equal to number 2. Since both are the same, so the result is again true. However, if I only use greater than symbol, the result would be false. To check the equality of both operands, uses double equals to the symbol. Like number 1 equals number 2. As both numbers are equal, the result is true. Similarly, you can find not equals to using exclamation mark followed by equals to symbol between the two operands. For example, number 1 not equal number 2. It gives you result false. As both numbers are not equal, so the inequality does not hold true here. First, I am defining two variables here, number 1 and number 2, with values. Now let's perform less than operations on them. So n1 less than n2 and run your code. As n1 is smaller than n2, result is true. Now again, you can check inequality operations on n1 and n2. So n1 does not equals to n2. As both these variables are not equal to each other, the result is true. Similarly, you can try other relational operators as well. To work with Boolean types true and false, logical operators are used. AND means if the operands are true at both ends, the result will also be true, otherwise false. OR means if either of the operands is true, the result will also be true. It returns false only if both operands are false. NOT simply means to negate the operand. The real-world example of the logical operations is the sign-in activity to your account. You need a password and a username, and if both of them are correct, then you are allowed to enter. Right now, to keep things simple, I am using a relational operator which you just learned and perform some logical operations on their results. Open Jupyter Notebook. Let me discuss logical operator. Type 5 is greater than 3 and execute it. Unsurprisingly, you get result true. Now perform such two operations and place a logical operator AND between them. Open parenthesis and type 5 is greater than 3, followed by keyword AND. Next, type 2 is less than 5 in a parenthesis. Run it, you will get true. What just happened here? Is the left-hand side after evaluation returns true as 5 is greater than 3, and also the expression enclosed in the right-hand side returns true since 2 is less than 5. As both sides after getting evaluated return true, the final result is also true as defined by AND operator. Now use the same expression by copy and paste it a new cell and just replace the relational operator is greater than with is less than. In the first parenthesis, keeping AND intact and run it, you get false as the expression on the left side after evaluation returns true, and if any side is false, the AND operator returns false. Coming to OR operator, let me repeat the same numerical example, but this time using OR. It returns true. It is like I'm asking the Python interpreter is less than 3, which is false, or 2 is less than 5, which is true. Since the operand on right is true, the answer is true, as OR implies that if any of these operand is true, it will be true. A real-world example as if you passed the aptitude test or scored greater than 650, you will get an admission. That is, if any of the class is true, that is, if any of the cases is true, you will qualify. Now move to the NOT operator. NOT is a unary operator, unlike AND and OR operators. So here type x equals true, which means I'm saying x is true. If before printing this variable I wish to invert its value, I can apply the NOT operator. So now type print inverse value of x. So here I will type is not x. So see the result? It states the inverse value of x, that is false. This is all about logical operators. You will explore the power of it once you use it with conditional statements and complex logics. There are some built-in mathematical functions as Python has a rich set of libraries. In this lecture, we will explore the math library Python has multiple built-in maths functions in its standard library. You can perform common math operations as well as trigonometric, logarithmic, hyperbolic, and angular functions. Here is a list of some common maths functions such as floor to get the lower bound value of the number, ceil for upper bound value. You can also calculate factorial of a number, call the pi function to get the value of pi. To find the remainder when a number is divided by the other, you can also use modulo operator, the percent symbol that you saw earlier, but a modulus operator always wrote a positive number, which makes it unsuitable if we have to use this operator with negative numbers. For this purpose, remainder function is there, and so on. To find trigonometric values of numbers during calculation, you can call built-in trigonometric functions such as tan, cos, sine, and etc. Then we have power and log functions to let us work out these in the lab. Now let me discuss built-in mathematical functions. Type import math. This library will be used to call math functions in the Python. The Python main math library provides us access to common math functions and constants which we can use throughout our code for more complex mathematical computations. The library is a built-in Python module, therefore you don't have to do any installation to use it. Now in a variable I am saving the value of pi from the library and print it. It gives the value of pi in the output cell. Let me calculate the area of circle, which shows you the usage of the built-in function. For clarity, I am adding some comments here. So the comment shows the formula of the circle, which is area equals to pi multiplied by the square of the radius. Let's calculate this in Python. Here I am using math.py and math.power method. First assign 3 to the variable radius. The math.power method returns the value of x raised to power y. So I am typing here area equals to math.py, which we have used earlier, and multiplied by math.power radius, 2. Here power method is calculating 3 raised to the power 2. Now run the code and it gives the area of the circle. We can also round off the result to any decimal places using inbuilt round method. Type round variable area, 3. Here I am rounding off the result to 3 decimal places. To get the floor value of area, use math.floor method. Now it shows the lower bound value of the variable as you can see here. To get the upper bound, use math.ceil method. Pass the variable area to it and it shows the upper bound value. Now math.truncated method is used to get the truncated integer value of number. Just gives the whole number before the decimal. As you can see here, all numbers after the decimal point are truncated in the result. Now I am finding the exponent of a number that we can use to calculate the power of e. So for that, type math.expression, pass any number as a parameter. Run the code and see the result. What is the e? It is the Euler number, which is the base of natural logarithm and is also defined in the math library. We can access it by typing math.e as it is a constant provided by the math library. The Python maths library comes with the log function. This function returns the logarithm of the specified number. The natural logarithm is computed with respect to the base e. So now type math.log and print math.py as an input value. In the script, we have calculated the natural logarithm of the pi constant. You can try with any other value such as math.log50. To get the base 10 logarithm of the specified number, type math.log10 and 50. Run the code and it gives you the result of log 50 in base 10. To find the square root of a number, use math.squareroot method. As we all know, the square root of 4 is 2. The Python math module support all the trigonometric functions such as sine, cosine, tangent, and the inverse of them. So you can also convert an angle from radian to degrees and vice versa. Let me show you some example. So type math.radian90 and save it in a variable number. Run the code. Now convert number back into degrees. For that, type math.degrees and pass number. These are just a few examples, so try some other methods of this library at your end to get hands-on experience. So in this lesson, you learn how to use built-in mathematical functions. The math module is used to access mathematical functions in Python. All methods are used for integer or real type objects, not for complex numbers. In the last section, we learned about numbers, and in this section, we will learn about string operations. In this lecture, we will learn about important concepts related to printing strings. A string is a sequence of characters that can be any numeric, special symbol, English character, or combination of enclosed in a single, double, or triple quotes. For example, a variable name holds the value of Sarah in a single quotations, book and age represent string values in double quotes, and reviews contain the value in a triple quotations. This is more clear representations of defining multi-line strings. If your string consists of more than one line, then use triple quotations to represent it. Till now, you learned what strings are and how to define them. Let me show you some examples in the Python environment. You already know how to store strings in a variable. Recall your lectures of section 3. Strings are the most popular data type in any programming language. Using strings, you can create, manipulate, or display textual information. Now, to create a string, you need to enclose it in a single, double, or triple quotations. Here I am declaring x as my string having a value 25. It is important to note that 25 is enclosed in a single quote, so it is not a number anymore. Let me define another string for you which says welcome skill curve in double quotes. So let's print this variable. And here it displays welcome to skill curve. Both are the correct ways to represent a string in Python. If a string itself includes a single quotation such as string 2 equals it's a sunny day, then I need to enclose such a string inside a double quotation. Print this variable using the print method. And here you get the result. It's a sunny day. Similarly, if a string consists of double quotations, then you need to enclose it in a single quotation. For example, I am a learner. Here the word learner is enclosed in double quotations. So here I will store my string in a single quotation. So now print your string and see the result it displays. I am a learner. What if the string consists of both single and double quotes? In that case, use triple quotes. For example, declaring a variable string 4 and opening a 3 double quotations. And now I'm opening 3 double quotations. Just copy this value, paste it here, and use the contraction I'm instead of I am. Now I'm going to print string 4. See the result? It displays I am a learner. Also, if a string spans more than one line, triple quotations are used, as you can see here in the example. Now here is a variable comments, and here the string spans 3 lines. Now print the value and it says, let's see what it displays. So in this way, you can deal with different types of strings and print them in Python. These are the different ways to print string literals in Python using the print method. One interesting thing to notice here is that a string variable can be multiplied by a number, unlike other programming languages. So here the variable name is multiplied by 3, and in response Python will give you the string repeated thrice. So you can use any number to repeat your string by using the asterisk. Each element in a string is represented by an index. Consider an example of variable language hold in value Python. Each character of Python is indexed in a memory sequentially. So if you want to print the entire string, use the print function and pass variable language to it as an input. And to access an individual element, type string name and followed by the square brackets and pass the index number. As the strings are indexed, they can be sliced using positive and negative indexing. So in this lecture, we have got a basic understanding of string and printing strings function. We will be practicing all the printing string functions throughout our strings labs sessions. And in the next lecture, we will learn about the string built-in functions. In the last lecture, we learned about printing string, and in this lecture, we will learn about string built-in functions. As we have seen with numbers, there are also string built-in functions. They return new string values rather than modifying the original strings. Let's get hands-on practice by performing these built-in functions. Many built-in functions perform different operations on a string. Since strings are immutable, you cannot do any operations that can change a string itself. First, I'm defining a string topic. Having Python is fun to learn as its value. Now let me print it for you. Now I'm going to tell you 3 useful string methods: upper, lower, and capitalize. The first method converts a string into uppercase. Next, the lower method changes it to lowercase, and the capitalize method changes string into sentence case. Remember, these methods returns a new string. It does not change my original string. You can also verify it by printing the original string topic and see the result. Next, there are methods to check the casing of a string, such as is lower. This method asks the Python interpreter if my string is in lowercase. So it says true as my string is in lowercase. Similarly, you can try it for is upper. Next, we have is alnum method. It returns true if the string contains all alphabetic or numbers with no space or special character in a string. Here I will type a variable address which says 50 North Garfield Lane. So this string consists of numbers, letters, and white spaces. Now I'm going to ask the Python interpreter whether it is all alphanumeric or not. So it returns false as it contains white spaces beside numbers and letters. Now let's remove white spaces from this string and rerun your code. So now it says true as it contains letters and digits only. You can also find whether the string consists of alphabets only using isAlpha method. It returns false as my string consists of digits as well. Let me define another variable here, address underscore zip. So this string represents the zip code of an address. Now I am going to find whether all the characters are numeric using isNumeric method. Now it says true. Similarly, we have another method isDigit. And here it gives a similar result. So what is the difference between the two? Let me show this using an example. IsNumeric works on fractional values as well, whereas isDigit returns false in such a case. Next, you can calculate the length of a string using length method. Here the variable contains value red, and you know well that it has 3 characters. We have to pass the string to this method. So it returns 3. This method is particularly useful to find the length of larger strings. You can also substitute a substring with another using the replace method. However, it will not create changes in the original string, but returns a new string. As you can see in this example, here I have typed a string, welcome friends to Skillcar. I want to replace friends with learners. We can do this using the replace method. First, pass value to be replaced, and next pass new substring. But you can always check your original string to gain a better understanding, as the original strings remain unchanged. Here you can save the result of replace method in another variable for later use. Next, we have a join method that returns a string in which the elements of the sequence have been joined by a string separator. Let me show you this with an example. Here is a string S3 which says, "Hi John, how are you doing?" If we join this string with white spaces and then save it in a new variable result underscore string, it will join each letter with white spaces. So here you can see that each element of the string is separated by white space. Now you can try this using 2 different strings and see for yourself. You can also break a string using the split method into a list by using the specified separator. The default separator is white space. S3.split and save it in S4, print S4. Here the string is separated word by word into a list. Now we have the count method that is particularly helpful to find the occurrence of a substring in a given string. Let me show you this with an example. Here we have an example of text 2. I love spring. Spring is my favorite season of the year. Next, I want to count the occurrence of the word spring in this string. So I used the method count and provided spring as an input parameter to it. And it says 2 as the word spring appear twice in my string. You can find the index position of the first occurrence of a letter or substring in a string. If not found, it returns -1. Let's suppose we want the occurrence of s in the same string variable text2. So I'm using the find method and passing s to it, and it returns 7, which means s is at index 7. The find method takes a maximum of 3 parameters. First one, substring to be found. Second one, starting index from where to start the search in a string. And the last parameter is ending index and is optional. So now I will use these 3 parameters to make it more clear to you. Here I am finding s in my string text2 from index position 13 till the last character. So I am using -1 for the last character here. And it returns 15 here. After 13, s can be found at index 15. Now we have another method, index, which works the same as find method. The only difference is that it will throw an exception if the substring is not found in a given text. Let me do this for you. Copy the cell and paste it here and replace find with index. It returns 7, but what I want to find the index position of z. It throws an error, but if I use the find method for the same case, it returns -1. So last but not the least, we have a stripe function, and it returns a copy of the string by removing both the leading and the trailing characters based on the argument. And the default argument is white space. In this example, I'm removing leading and trailing white spaces using this method. However, the white spaces in between will remain unaffected. And the answer is mango is my favorite fruit, which contains no leading and trailing white spaces. You can pass any character as an argument to this method. Let's stripe man from the value this new variable z. All white spaces and the characters MAN in the left and right of the string are removed. So now here is the result. Go is my favorite fruit. See, man is removed from the string. So you can practice more with all built-in string methods to get more practical experience over string functions. In the next lecture, we will practice about string formatting. In this lesson, you will learn different approaches to string formatting in Python. String formatting allows you to control the format of the output string. The question can come into your mind, why should I use a string formatting? For example, you want to print bill or invoice, or want to control the printing of digits after the decimal point, or something else like to place a $sign in the middle of a sentence with an amount. Then you can use this method to format the output of the program in a way you want. Python cannot concatenate a string and integer. These are considered two separate types of objects, but to concatenate them, the format method can be used. For instance, you want to write, I have 3 books and 2 pens. This can be done using the format method. Now let's open up your Jupyter Notebook. As we learned earlier, we cannot combine strings and numbers using the plus operator. Let me recall this for you. Here we are defining two variables, age and sentence, which says, I am Sarah and I am. Here I am going to concatenate age variable with 23 years old. So here instead of typing 23, we have concatenated age in the sentence. So let's print and see the result of this. So here it returns only the error with that it cannot be concatenated with the integer. so we cannot combine strings and numbers using the plus operator. However, you can use the format method provided by Python to do the job. In the format method, you need to use curly brackets as your placeholder. Let me show you an example using the same two variables, age and sentence, but instead of concatenating age in the sentence, I am going to add a format method here. Now this method takes the arguments, formats them, and places them in the string where the placeholders are. Here I have defined two variables, age and sentence. Notice the position of curly brackets. This is the place where I want age to be fit in. Now to print both values together, I am using the format method. So how simple and easy this format method is. Let's try an example I discussed in the slide. Suppose you want to write, I have 3 books and 2 pens. So using the format method, we will format this. Notice I have placed placeholders instead of numbers. Now when I am going to print this, I will use the format method and pass the numbers as a parameter. Now run your code to see the result. So here it returned, I have 3 books and 2 pens. You can use positional or keyword arguments here too. For complex formatting, you can use different types of codes. For example, D for integers, F for floating point, E for exponential data, S for string, and B for binary. Let's practice some of it. Format method takes an unlimited number of arguments and places them into the respective placeholder. Now I am going to introduce 3 variables: quantity, item, and price with some of their appropriate values. Next, I want to say I bought 3 donuts which cost $3.95. For this, I am creating a sentence and passing 3 placeholders at the appropriate positions. So now I'm going to print this sentence using the print method, and we will pass the quantity variable, item, and price variable. So now after running your code, it says I have bought 3 donuts which cost $3.95. The placeholders are replaced in the same order in which the values are specified. That is, the placeholders are replaced with values starting from index 0, 1, and then 2. The only condition in multiple formatting is that number of placeholders and the number of values specified should be equal. What if the numbers of values is less than the number of placeholders? So let me add a placeholder in the string like this and run your code. This raises an index error since Python does not find a suitable index for a specific placeholder in the string. What if the number of values is greater than the number of placeholders? And let me show you an example of it. Here I am declaring a string with 2 placeholders and 3 parameters in the format method. Run your code and it says I have bought 3 donuts which costs $. So you see it did not raise any error, since the placeholders are replaced by values beginning from index 0, and once all the placeholders are filled, Python does not look for replacing any more values if there are no more placeholders to replace. Python supports different types of arguments in the format method. We will discuss all of the other methods in the next tutorial. In the last lecture, we learned about the string formatting, and in this lecture, we will have a look at some formatting example. Python supports positional and keyword arguments. This is an example of positional arguments, wherein placeholders pass the position of the argument that is to be evaluated upon execution. Let's try these examples in Jupyter Notebook. Here I am giving you examples of positional arguments in the Python script. In format, method indices can be passed as values for placeholders. Let me reuse the previous example, but this time using positional arguments. 0 maps to quantity, 1 maps to the item, and the third placeholder maps to price. Run the code and it returned I have bought 3 donuts which cost $3.95. When we say positional arguments, we mean that if I have to format a string and add 3 values in place of 3 placeholders, by default the placeholders are replaced in order. But by specifying positional arguments, I can replace the placeholders with any value I want. All I have to do is to mention the appropriate index value in which the values are passed to format method. Let me show you an example to make this clear. The first print statement uses the indices of the arguments in the format method in the same order to assign values to the placeholder. The second print statement uses the indices of the arguments in the format method in the same order to assign values to the placeholders. The second print statement indicates that the indices can be mentioned in any order, and this corresponds to the order in which the values are assigned to the placeholder inside the format method. Here 1 maps to the second argument inside the format method, that is lecture 17. Similarly, 0 maps to the first argument of the tuple, which holds element string formatting. The third statement implies the same thing as that of the second statement, but uses 4 positional arguments to make the point clear. So now, let me run this code for you, and it returns, I love Python. The lecture is about string formatting. Notice the use of positional argument in this line. Python is the most widely used programming language, and in this way, you can use positional arguments. In example 3, we format floating point numbers to up to 2 decimal places using format specifier .2f. And in example 4, the string is formatted. Let's also practice this in the Jupyter Notebook. So far we have used positional arguments, but Python supports keyword arguments as well. The placeholder with the format method can also have a key name inside the curly braces, and this placeholder key is assigned with a value inside the format function. Let's say I want to type a sentence which says, Sarah has 3 notebooks, 2 pencils, and 1 eraser. Now, how to format it using keyword arguments? So instead of just leaving blank placeholders, pass keywords to it, and that will be used later to supply value using the format method. And here I am passing 3 keywords S1, S2, and S3. Later I am using the format method and passing keyword arguments with values. So S1 is equals to 3, S2 is equals to 2, and S3 equals 1. Now look closely to the format method, where in format book equals 3, pencil equals 2, and eraser equals 1. Here S1, S2, and S3 are all keyword arguments with a value. The positional arguments as well as keyword arguments can be combined and passed together when required. I'm adding a code snippet which demonstrates how the positional and keyword arguments can be passed to the format method. This statement says Python is a great choice for beginners. It is important to understand that all the positional arguments must follow keyword arguments, else you will get an error. For example, if I pass st before positional arguments and run this code, so you get a syntax error which says positional arguments followed keyword arguments. That is, first declare all your positional arguments and then pass any keyword arguments. This is how you used keyword arguments in Python. In the next lecture, we will discuss some more examples of string formatting with specifier. In the last lecture, we practiced some examples related to string formatting, and in this lecture, we will practice some more examples of the same topic. In example 5, here positive and negative numbers are formatted, whereas in example 6, we align string text. Moving to example 7, we add a comma separator in our digits to represent a large number, and in example 8, we format the number into its binary equivalent. In the last example, we use the % format in our text data using the % symbol in curly brackets. Let's practice all these examples in Jupyter Notebook. While formatting strings, remember that they are left justified, but this can be easily changed by specifying alignment format specifier. Let me show you an example. Copy the above cell and paste it here. Type colon, caret, 10. Run the code and see the result. Now you can see Python is centrally aligned. You can use the greater symbol for left alignment and less than symbol for right. Let me do one for you. Now Python is aligned to your right. Let's look at the numbers and floating point formatting. Let me show you an example demonstrating how to print a number or an integer using the format method. Type print 0 as positional argument, $d, which specifies an integer value, and in format method, pass an integer 12 to it. Run the code and see the result. Now copy the cell and paste it here. Type 5 before d. The total width of the number becomes 5. Since no alignment is specified, it is aligned to the right. Let me do left alignment using less than a symbol and run this code. Now the numbers are aligned to left. You can pay them with zeros as well by placing a 0 before the format specifier. It works both for integers and float. So now see the result. Now let's come to format floating point numbers. Suppose I want to print the value of pi, that is 3.14157, as it is a floating point number, so I will use f here in the placeholder. So this is basically my floating point number. You can also specify digits of precision after floating point. Copy this cell, paste it here and type .2f. Here I am specifying 2 digits of precision in the result. Just tweak it a little and change it to .3f and see the difference. Now the value is rounded off to 3 nearest decimal places. Let me show you another variation. Type 8.3f. And see, it truncates the decimal part into 3 places, rounding off the last 2 digits. And the number now 3.142 takes a width of 8 as a whole, leaving 2 places to the left. You can also format long integers if you want to place commas at appropriate places. Use a comma in the placeholder and Python will do the rest for you. This example says the universe is 13 billion years old. Here the commas are placed automatically since we have used a comma in the placeholder. You see it is formatted with the commas. You can print positive and negative numbers just by passing plus or negative in the placeholders. Let me show you an example. In this example, the first print statement displays a plus sign, the next explicitly shows a negative symbol, and the last print statement specifies space instead of a plus symbol. To find the binary version of a number, use B in the placeholder. For example, I want to find the binary equivalent of 5. So print the binary version of 5 is 0:b.format5. The output says the binary version of 5 is 101. 101 is the binary equivalent of 5. Numbers can be formatted into percentages as well using the percent sign. The example shows you a text you scored and in the placeholder I typed .0%. In the format I passed 0.25 as an argument, run the code and you scored 25%. Here my floating point value converted into a percentage. This is how you can do number and string formatting using the format method. In this section, we will cover the conditional structures in Python. And in this lecture, we will see how to write if statements and if-else statements. So, what are the conditional structures? It is something you do every day, and it's about evaluating conditions. For example, if the light is green, then I will cross the road. Or if it is not cold outside, then I am playing with my friends and so on. So you are making decisions every day and action depends on whether the condition is true or false. If statements comes in various forms. The condition in if statement is evaluated and based on condition, the block of the code is executed or skipped. The flowchart shows the flow of decisions. If it is true, then the block on the dark box is executed, otherwise control exits out of the if statement. The general syntax is if, then a condition followed by a colon provides the desired statement or statements you wish to execute in case your condition is met. Before I talk about other variations of if statements, let me start by a simple program. Imagine we want to write a program that uses conditional statements. What if I am late to catch my flight? Obviously, I miss my flight. Let's translate such an example into a Python code. Here I am defining a variable late and set its value to true. Now using the conditional structure if, I'm testing it against my variable. After providing condition, type a colon as it is the part of the syntax. Next, I am passing a statement that I wish to execute if my condition is evaluated to true. And it says I will miss my flight. While passing single or multiple statements as the body indentation is mandatory, otherwise Python interpreter will not consider it a part of the if block. I'm adding 2 more print statements just to make my point clear. Now let me run this code and here's the result. It says I will miss my flight dash and end of if. As we know that if executes only when the specified condition is true, and here since my variable is already set to true, therefore the body of if is executed. Let me modify the value of my variable to false and see the output. Now if block is not executed at all. Let me show you another example. Number equals 5. If number is greater than 0, number is positive. So the output will say the number is positive as 5 and is greater than 0. Next, we have an if-else statement. Again, a condition is evaluated. If the condition evaluates to true, if block is executed. Otherwise, this time we have an else block. If the condition goes wrong, then else block is executed. The syntax of if-else statement is if followed by a condition and a colon, and press enter that you wish to execute if the condition is favorable. Otherwise, type else followed by a colon, then again put statement that you want to execute if your condition fails to meet. Remember, you cannot pass any condition for testing in the else statement. What if we have more than one conditions? If the condition evaluates to true, its concerned block is executed. If it fails to meet given criteria, then the interpreter evaluates the second condition, which is present in elif. Again, if it evaluates to true, then the concerned block is executed. Otherwise, the next elif statement is going to be evaluated until you reach the end of it. Finally, if no condition matches, you can provide a simple else block. This is also called ladder if-else in the programming world. Let me explain both if-else and ladder if-else using some examples. Now, how about comparing two numbers? I'm defining two variables, number 1 and number 2, with values 2 and 5 respectively. Next, I want to find which number is greater. So I write number 1 is greater than number 2, followed by a mandatory colon, and press enter. Notice the indentation. It represents if block, and in the print statement, type number 1 is greater than number 2 in print. And if not the case, then create an else block, type else followed by column, and type number 2 is greater than number 1 in the print method. Remember, you cannot pass any condition after the else keyword. Now run the code, and it says number 2 is greater than number 1. What happened here is, first, the condition in if the statement is evaluated. Number 1 and number 2 are replaced by their respective values, as 2 greater than 5 returns false, so the control transfer to else block, which says number 2 is greater than number 1. You can try other values to see the difference in the output. For example, if number 1 is 12, then output is number 1 greater than number 2, as 12 greater than 5 returns true. Now consider another example using string. Here my string is hello. Now I want to find the presence of characters O in my string. For this, I am going to use if-else along with membership operator in. Let me type the condition if O in string, print O is present in the string. Otherwise, write an else block which says O is not found. Now run the code and see the result. It says 0 is present in the string, as the letter O is present in hello. You can check for other letters as well. You can have more complicated cases in the real-world scenario where you can use if-else statements. To give you an idea of it, I am demonstrating a classical sign-in problem here. Let me enter the code snippet here. Here I am taking user input into username and password and testing it against a hard code value in my if condition. If both username and password matches, then the credential is authenticated, otherwise not. If the condition is evaluated to true, then it will print logged in successfully. Otherwise, it will say incorrect username or password, and try again. To implement this, I am using if-else along with logical operator AND. Recall the AND operator. It returns true if the expression on both sides also evaluates to true. So if we provide both the correct username and password, then the body of if is executed. Otherwise, else block will be executed. Let me run the code for you. It asks for username and I am typing admin@skillcurve.com and for password 123. And it says logged in successfully. Run the code again with an incorrect input. So for example, type admin for username and password 123. Now it says username or password is incorrect. Try again. This is how if-else works. Now if you want to check more than two conditions, you can use the ladder if-else. And in Python, we use the elif statements. It allows you to check multiple expressions for true and executes a block of code as soon as one of the condition evaluates to true. Similar to the else, the elif statement is optional. However, unlike else, you can pass condition here for evaluation. I have already written a code snippet for you. First, let me explain it line by line. Here I want to find a bonus according to the designation and update the salary of the employee. First, I declare three variables: salary, bonus, and designation. Now I have implemented my condition based on designation. As you can see, the if and elif statements. The first condition is if the designation is equals to clerk, then the bonus will be $100 and the salary will be updated likewise. But if the designation is not clerk, then move to elif and test designation for junior developer and so on. After defining all conditions, print bonus and final updated salary. Run the code to see the result and it asks for designation. Suppose I enter clerk here. It says you earned a bonus 100 and your salary for the month is $5,100. What happened here is when the evaluation started, the first if statement matches the criteria. So the bonus is set to 100 and the salary is updated. Run the code again with a new value. For example, I entered clerk last time and this time I enter team lead. Now this particular block is executed, which sets the bonus to 1500 and the salary is updated with this bonus. This is how ladder if works in Python. In the next lecture, we will have a look at other conditional structures such as nested and switch statements. In this lecture, we will discuss nested if statements and switch statements in Python. Moving on to the nesting, that is passing one if inside another. Nesting control statements make us check multiple conditions. It is another variation of if statement, the nested if condition, and there are scenarios where we want to check two conditions one after the other. In that scenario, use the nested if statement. One if is nested in some outer if statement. The inner if is evaluated only when the outer if statement is evaluated to be true. Otherwise, the code simply exists from the outer if to some other code or to the end of your code. If outer if is evaluated to be true, then inner if is tested against some condition and code inside inner if is executed if its condition is met. To remove any sort of confusion, let's open your Jupyter Notebook and write a small program. Nested if statements mean an if statement inside another if statement. For example, I want to check if the number is positive, negative, or 0 and display an appropriate message. For this, I can use nested if statement. Here I am declaring a variable number with value 3. First, in outer if, I check whether a number is greater than or equal to 0. If yes, then enter into nested if block. Next, I test whether the number is equal to 0. If yes, then print message. Number is 0. Otherwise, print number is positive. Now, if the outer condition evaluates to be false, then print a message, number is negative. Now run the code and see the result. It says the number is positive as 3 is a positive number. Try this program with different input values and see the result. For example, if the number equals negative 3, the output displays number is negative as -3 is a negative number. This is how nested if-else works in Python. Next, we have a switch statement. Python does not have a switch case statement like other programming languages, but we can use a dictionary to implement it. Consider the example. Here I have defined a dictionary called colors with keys as numbers and values as strings. Then in the print statement, I called a dictionary method get and provide two values in it. The first is the key against whom I wish to have a corresponding value, and the second is the default value set to -1. You need not to worry about the dictionary as you will learn in Module 7. Python uses a built-in dictionary that constructs to implement a switch case. Dictionary will be discussed later in the Module 7. Here is a code snippet to demonstrate the implementation of the switch in Python. I have declared 3 pairs value. I have declared key value pairs inside a curly bracket. These key value pairs represent discount codes and amounts respectively. Now, the customer code variable is set to D007. To find the discount amount, I called my dictionary of key value pairs using the get method. In the get method, I passed 2 arguments, customer_code and 0. It looks for the desired coupon code in my dictionary, and if found a match, returns a discount amount, otherwise it returns 0. So let me run the code, and it says discount offer is $2, as D007 is a valid discount code. You can try with some other discount code and see the result. For example, F100. Now run the code, and it says the discount offered is $25, as F100 is mapped to 25. Here the get method acts as a switch and works on customer code, and 0 is the default value, which means if no matching code is found, then it will return 0 in answer. Let me try one for you. For example, customer code is now F1300. Now run the code, and it returns 0 as a discount value. You can pass any value to set the default value. You can try this construct to implement a switch in Python. By using conditional statements like the if statement, you will have greater control over what your program executes. To continue practicing conditional statements, try using different operators, combining operators with and, or, and using conditional statements alongside loops. In the next lecture, we will cover loops in Python. In this lecture, we will learn and practice about the loops in Python. Imagine a situation of printing your name 100 times in Python. You may end up writing a print statement 100 times. Here comes the loop to our rescue. To execute a single line or block of statements repeatedly until a given condition is satisfied, we use them, and when the condition becomes false, the line immediately after the loop in the program is executed. Now there are two types of loop in Python, for loop and while loop. For loop is used to iterate over a sequence, and that sequence can be a string that you have learned in a previous module, or sequence can be an advanced data type such as a list or tuple. Let's talk about the syntax of the for loop. You need to start with the keyword for, followed by any variable of your choice, and after that, you must provide a range or sequence to it. Next, you must type a colon. After colon, one or more statements can be written with an indentation that you wish to repeat for a given number of times. Any statement that is not indented is not a part of the for loop. The flowchart represents the flow of execution. For loop traverses through a sequence until it reaches the last item. If the last item is not reached, the body of the loop is executed. Otherwise, it exits the loop. For loop is similar to for each loop in other languages. Here I traverse through the string using for loop and using I as the loop variable. Each iteration sets the values of I to the next element of the string. So first it will be P, then Y, then T, and so on. In Python, for loop can have an optional else block as well. The else part is executed if the items in the sequence used for loop exhausts. Else block is rarely used in practice. Now to make things clear, let us write some code. You may have noticed the format of writing for loop is closer to the English language. First, I am going to declare a variable course with value Python. Next, I am going to use for loop to traverse it. Type for x in the course followed by a colon, hit enter. You can see the indentation here. This is the body of the loop. This indentation is mandatory as discussed earlier. Next, I am going to use the print statement and pass my looping variable x to it as an argument. Now execute it and you get the letters one by one in the output cell. This is how the for loop works. What if I wish to print Python 10 times? I can print it using 10 individual print statements, but it becomes tedious if I increase the count. For such cases, loops are preferred. To loop through a set of code a specified number of times, we can use the range function in Python. First, let me introduce the range function to you. In simple terms, range function allows the user to generate a series of numbers within a given range. It can take up to 3 arguments. The user can decide where that series of numbers will begin and end, as well as how big the difference will be between one number and the next. Next, I'm going to use the range function with one argument in a for loop. Declare a variable number equals 10. Type for I in range, number followed by a colon and hit enter. Now write a formatted print statement which says Python dot format and pass the looping variable I to it. Run the code and see the result. Python is printed 10 times and the range of numbers starts from 0 till 9. This is how you use the range function with one argument. You can change the value of the variable and see the difference in the output. In the next example, I am going to use the range function with starting and ending values and is used to print values from 10 to 20. Type for x in range 10, 20, print x. Run the code and see the result. It displays the numbers from 10 to 19. You can also use for loop in combination with an if statement to make it more powerful. Now let me show you an example of it. Let's say I want to print even numbers from 1 to 20. So for that, we will provide this range in the for statement. So write for x in range 1, 20. Hit enter. In the body of loop, type if x %2 equals 0. That means I want Python to check the remainder of the looping variable after dividing it by 2. As we all know that numbers completely divisible by 2 are even numbers. So if the modulus operator returns 0, print it, otherwise skip that number. Now run the code and it displays 2, 4, 6 till 18. These are all even numbers between the specified range. Up till now we have learned the for loop, and in our next lecture we will learn about the while loop and nested loop. In the previous lecture we learned about the for loops in Python, and in this lecture we will learn and practice about the while loop and nested loop. While loop is used to execute a block of statements repeatedly until a given condition is satisfied, and when the condition becomes false, the line immediately after the loop in the program is executed. We generally use this loop when we don't know the number of times to iterate beforehand, and the general syntax is while condition followed by a mandatory colon, and then write the body of loop using indentation. Python uses indentation as its method of grouping statements. The first unindented line marks the end. After the while is over, you can put any statements or logical code that you want. If the statement in while never becomes false, then the loop will never end, and you fall into an infinite loop and your program never exits. Keep a check of it while coding. Now that you get familiar with the while loop, let's run an example of it. Let's print the first 10 natural numbers using a while loop. Define a variable and say n equals to 1. This is the initialization of the looping variable. Now define while loop using its syntax. Type while n less than 11 and followed by a colon. Hit enter and type body of loop, print variable n in it. Next, increment the looping variable so that it reaches 11 after 10 passes, and condition in while loop evaluates to false. Failing to do so will result in an infinite loop, that is, never-ending loop. So let me write an additional print statement which states that end of the while loop. Now run the code and you get the first 10 natural numbers in the output. Once the while loop is terminated, the print statement is executed. Now let me show you another example of the while loop. Let's calculate the factorial of a number. As we know, the factorial of a number is the product of all the integers from 1 to that number. It is time to build our logic. Now declare two variables, factorial and number. Set factorial equals 1 and number to any value whose factorial you wish to calculate. Type while number is greater than 0. Multiply factorial by number and save it in the same variable, factorial. Decrement number by 1 in each pass so that it reaches to 0 finally. Once we exit out of the loop, I will print the value of the variable factorial. Execute the code, and finally the result is displayed. The value of factorial is 24. You can print the value of variable fact in each pass to gain clarity. That is, you can write a print statement here and print variable factorial here. Now see, in each pass, it multiplies with number and saves the result in factorial for the next iteration. and finally you get the value of the factorial. You can use one loop inside another loop, and this section illustrates the concept of the nested loop to you. You can put any type of loop inside of any other type of loop. For example, a loop can be inside a while loop or vice versa. First, the outer loop condition is evaluated depending on the type of the loop you use, and it's set to true or non-empty in case of for loop. Then you will enter the inner loop. Nesting is mostly used with advanced data types. Now let's code an example of nesting loop. Nesting a loop means simply having a loop. Let's call it an outer loop that has inside its commands another loop called an inner loop. Let me explain an example of nested loops here. You can use a combination of while and for loops, two while loops or two for loops. Here I am using two for loops together. Run the code to see the pattern. Here is the triangular pattern for the asterisks. We need two for loops, one for rows and second or inner for loop for the column. Here we again used range functions. The outer loop is executed 6 times and the inner loop is dependent on the outer for loop for each pass. In the first iteration, I is 0 and so the ending of j is 0. And nothing is printed but a new line is added in the output. Next we have a print statement where we used the end keyword. By default value is a new line, but you can change it here. I want this print statement not to change line, instead append the string. In the next iteration, I is 1 and the inner loop is executed once, so one asterisk is printed and so on. The statement in the next print statement is used to change a new line. Once the inner loop is exhausted, this print statement is executed and a line is changed. Finally, when both outer and inner loop terminates, the else block is executed, which says end of loop. I hope you have got an understanding on how to use while loop and nested loop in Python. In the next section, we will learn about the data structures in Python. Hi, welcome to section 7, working with data structures in Python. In previous lessons, we discussed variables, their types and how to manipulate them and perform operations on it. Let's have a bit more depth into the variable. A variable can store one piece of information at a time only and can be modified, but what if you need to store a long list of information that does or does not change over the period of time? In Python, we have 4 basic inbuilt data structures: list, tuple, dictionary, and sets. Every data structure stores data differently and different operations can be performed on them. In the upcoming sessions, we will be discussing each of them separately in detail. In this lecture, we will learn about list data structures and we will also have some hands-on practice of list data structures examples. To hold a collections of values, we can use lists in Python. It can be used for any type of object from number and string to other lists. Lists in Python are indexed and we can access list just like a string that we have done in the earlier sessions. And so they are simple to use and can be of different length. They can also grow and shrink automatically. In reality, the list data structures is just like an array in other programming languages. List is an ordered and mutable collection of data. That means it can be changed once defined. In Python, lists are written with a square bracket. For example, here is a variable called veggies. It is basically a list, as you can see that carrot, potato, and cucumber are enclosed in square brackets. You can print your list using the print function. Give parameter veggies as an input to print function and the output you will see will be carrot, potato, and cucumber. Each of the item can be accessed using their index numbers. For example, if you want to access carrot, you can simply use 0 in the square bracket after typing veggies in print function, and you will get the result carrot. Similarly, if you want to access potato, you can use the index number 1. Let's try this out in the Jupyter Notebook. As discussed in the slides, let me create a list of veggies and put some values in a square bracket. Let's say carrot, potato, onions, turnip, and broccoli. Now if I print this variable veggies, the output cell will show me the list of veggies. As lists are indexed collections, you can access individual element of the list using an index number in a square bracket. As we know, there are two ways of indexing, positive and negative. In positive indexing, each element has an index which increases from left to right. To access the first element, use index 0. Type the name of your list veggies and pass the index 0 in the square brackets. It returns carrot, the very first member of the list. Potato is associated with 1, turnip with 2, onion with 3, and broccoli with 4. If I say veggies with index 4, it returns broccoli. Notice that even my list has 5 elements, the indexes go from 0 to 4. So if I ever use index 5, I will get an error because index 5 does not exist in the list. Now in negative indexing, the last element of the list has an index of -1 and the second last element has an index of -2 and so on. So let me show you an example to access the last element of the list. Provide -1 in indexing and it will return the last item. As you see, it returns last element, that is broccoli, from the list. You can access a range from a list by specifying where to start and where to end in a square bracket using colon. Type veggies, square bracket, open, 2, colon 4 and close the bracket and then run it. It returns turnip present at index 2 and onions located at index 3. But the value at index 4 is not returned. The range works this way that the ending element you specify will be excluded from the list. You can also leave the starting index and pass ending index in bracket. In this case, 0 will be the default index. So if I run the code, I get a list from index 0 till index 4, but again index 4 is excluded. Now I am demonstrating an example of specifying range using a negative index. Type veggies -2 colon -1. This example returns one item from index -2. Item at index -1 is excluded. It returns onions only. As onion is at index 2, which is my starting range position, and element at index -1, broccoli is excluded as -1 is my ending value in the range. So you learn how to create a list, then assign it to a variable name or an identifier. And you learn how to access elements using indexing. Remember, the order of the objects in your list matters. There are more operations which can be performed on list. So in the next lecture, we will be performing some operations of list data structures. In this lecture, we will learn about the list operations, and we will also do some practice on different examples of list operations. We can perform multiple operations over list. If you want to repeat each element of a list, simply multiply your list variable with that number. That is, if you want to repeat the list elements twice, then multiply your list variable by 2. To repeat them thrice, multiply it by 3. We have the concatenation operation, in which you can concatenate lists together. Here we have L1 having element 1, 2, 3, 4, and we have another list L2 with elements 5, 6, 7, 8. If we perform concatenation using plus symbol, then the output will be 1, 2, 3, 4, 5, 6, 7, 8. First 4 elements are from list L1 and last 4 elements from list L2. You can concatenate any number of lists together. Let's practice these examples in Jupyter Notebook. You can perform different operations on list such as iteration, concatenation, repetition, insertion, deletion, etc. First, let me tell you about concatenation. I'm going to concatenate two lists. First, I'm going to define another list of fruits and pass some values in a square bracket. Now I'm going to use add operator to concatenate veggies, the list which we declared in the previous lecture, and fruits into a new list. Now print this list using the print function. You see a new list having items from veggies and fruits lists. Notice that your original lists, that is veggies and fruits, are intact. That is, there is no change in them. Or use the extend method to append a list, say fruit, into another without creating a new list. Type veggies.extend fruits. This particular line will add items of fruits into veggies. Now print veggies either by using print function or simply by using name of the list. You can see a list here which is the combination of items of list, fruits and veggies. This is how we do concatenation in Python. Let me do some other examples for you. How to repeat each list element for n numbers of times. Let me declare a simple list of numbers L1. Type some numbers here. Now multiply this list by 2. See, each element is repeated twice in the list. You can use any other number here and see the difference in the output cell. This is how we perform concatenation and repetition over lists in Python. You can also find the presence of an element in a list using membership. Let me recall you, we have multiple operators out of which there is a membership operator, in and not in. Here the membership operator will try to find whether 2 belong to the list first or not. If it is in the list, then it will print true, otherwise it will print false. By this time you are familiar with the for loop. Here, the for loop is used to iterate over each element of the list, any list, and print its element one by one. Also, we have many methods associated with the first list. For example, to find the length of the list, use method length. To find minimum and maximum elements of a list, use min and max functions. You can also sort your list with a simple function and add elements in your list using the append function, as I told you that lists are changeable. To delete elements of a list, use remove method, and to delete a list, use del method. Let's try all these functions over the list in Jupyter Notebook. Moving on to the other operations on a list, such as iteration, recall that a loop can be used to iterate through sequence. Here the sequence is the list of veggies. Let me iterate through elements of list using for loop. For x in veggies, now I am going to print the value of x here. Run the code and see the result. The output shows the result of traversal. Unlike strings, value of a list can be modified. Here I am modifying the value at index 0 with capsicum. As you can see now, we have capsicum at index 0 rather than carrot. Hence, the value is modified in the original list. You can not only modify a list, but you can also add new values in it using function append. Type veggies.append and pass beetroot value. Now print the list here. Output cell shows the new value at the end of the list. You can also find the length of a list by using function length. Type length and pass the name of the list to it as an input. The output cell returns 9 as we have total 9 elements in the list. You can also insert an item at a particular index using the insert function. The insert function works with two input parameters. The first parameter asks you for the index where you want to add an item. Let's say I want to add item at index position 2. And in the next parameter, pass an item value or list of values. Now run this code. See, the cabbage is inserted at third position, that is at index 2. To remove an item from the list, pass its value to remove function. Type veggies.remove and pass any value that you want to remove. Let's say I want to remove apple from the list. Now see the output. Apple is now deleted from the list. To remove an item from a location, use delete method followed by list name with index. For example, I wish to remove potato from the list. So type del veggies and pass the desired index number to it. Now run the code. The element potato is deleted from the list. There is another method pop. It always removes last element from the list. Type veggies.pop. It requires no arguments. See, the beetroot is removed from the last of the list. You can also copy one list into another. Let me declare an empty list, my list here. Print it and the output cell shows an empty list. Now let's assign veggies.copy to it and print my list. It now carries all values of veggies in it. There is also a built-in list functions to sort elements alphabetically. Let me apply this method on my list. Type mylist.sort. Now run this code. You can see the list is now arranged alphabetically. You can also find minimum and maximum value from a list. Here we have a list of strings, so let me apply max on it. It returns turnip, as turnip is the one that is at the bottom of the alphabetic arranged list. Next, apply minimum. It returns broccoli as it is at the start of the sorted list. You can also apply these methods on a numbered list as well. For example, we already declared a numbered list L1. Let me find maximum value of list L1. It returns 5. And minimum returns 1. So this is it for lists. However, you can do some more experiments with it and try some more functions with it. You can also create a list of lists here, but I will leave this for you to explore. In the next lecture, we will discuss about the tuple data structures. In this lecture, we will learn and practice tuple data structures in Python. Tuple is a collection which is ordered, that its sequence is maintained and immutable, unlike list. Once you define a tuple, its value cannot be modified later. Tuples are comma-separated values in a round bracket. You cannot remove items from it. However, you can delete the entire tuple using the keyword delete. Duplicate members are allowed in a tuple. Tuple has two built-in methods, count and index. I will demonstrate both later in the lab session. Moving on to the accessing methods of a tuple. To declare a tuple, use a variable, let's say tpl here, with the values 1, 2, 3, 4, 5 enclosed in a round bracket, which is the identity of a tuple. And next, we can print it out using the print method. If you run this code in Python environment, you get output 1, 2, 3, 4, 5. To access individual elements from tuple, you can write tpl and in square bracket pass the index that you want to access. To access a range of values, you can provide that range using indexing in square brackets. Just provide starting and ending index separated by colon. To delete a tuple, you can use the method delete and then provide your tuple name after a space. A tuple is a comma-separated list of values usually enclosed in parentheses. But parenthesis is not mandatory to define it. Now I am going to declare two tuples. Let me define a sequence of numbers from 1 to 5 in a parenthesis. And we have tpl2 with comma-separated values. Both of them are tuple. Now print each of them in print function. See, both of tuple are represented as tuples in the output cell. For confirmation, you can use the type method. Type tpl1, it returns tuple. Type tpl2. It also returns a tuple. But usually when we define a tuple in Python, we use parentheses. Tuple can also be created with mixed data type. Let me show you one. tpl3 equals cat 12 true and 36.56, that is float value. Now let me print it. This is also a valid tuple, having values cat 12 true and 36.56. You can create a tuple with a single element. However, it is necessary to have a trailing comma in parentheses. Suppose I type T1 and assign only a single character A without a trailing comma. It will not be considered a tuple but a string. So here the output also shows A with no parentheses. To confirm it, let me print the type of object T1. And you can see the data type of T1 is string, that is string and not a tuple. Now adding comma at the end of A and executing the code, now T1 is a tuple. Elements can be accessed using indexes just like lists. type TPL1 and in square bracket pass index 2. It returns 3 as we have 3 at index number 2 in our tuple TPL1. Now type TPL minus 1. It returns the last element. To access a range of values, specify it similar to what you have done in the list. Type TPL1 and in square brackets provide a range 2:5. Run the code. It returns 3, 4 and 5. The element 5 at index 4 is returned in the result along with other two values. But there is no element at index 5. Remember, range excludes the index specified in the ending position of range. You cannot modify a tuple once it is created. However, you can delete the entire tuple using delete method. Type delete TPL1. This deletes the tuple TPL1. Now if you try to print TPL1 in the next cell, it will give you a syntax error, as TPL1 is not defined as it is not present in the memory anymore. In our next lab session, we will look at a few more operations on tuple. In this lecture, we will learn and practice about the tuple data structures operation. Just like list, you can perform multiple operations on tuple. You can repeat the elements in a tuple and you can iterate through tuple using loop. You can also find an element in a tuple using membership operator and tuple length. Let's perform some operations in Jupyter Notebook. Let me define a tuple of colors having values red, yellow, green, and black. Print the tuple. Now, I would like to iterate each element using for loop. Using the syntax of for loop to iterate the sequence, type for x in colors. Print your looping variable x. In the output cell, you see the values printed one after the other. Tuples also allows repetition of operations. Here I am multiplying my tuple colors with 3. Now each element will appear twice in the tuple. But this operation results in a new tuple rather than modifying original tuple. To check this, print tuple colors in the next cell. See, there is no change in the original tuple. You can also use membership operator in or not in to find the existence of an element in a tuple. Here I am taking user input to find the existence of a color provided by the user in my tuple. Now employing if-else to do the job. Type if user in colors, then print it is found in colors. Otherwise, print it is not found in the tuple. Now run the code to see the result. Here I typed red. It says red is found in colors. You can try different input values and see how it works. Now I'm going to find the length of tuple using length method. Print colors. The output shows the result 4 as there are 4 elements in the tuple. As tuples are immutable, you cannot add or append value in it. Let's try it by assigning new value white at index 0. Now print tuple colors. the interpreter will throw an error that object does not support item assignment. You cannot remove items from a tuple, but delete the whole tuple as I told you earlier. Concatenation can also be performed. Use plus operator to concatenate two tuples, which results in a new tuple. Here I am defining a new tuple, colors2. Done with the values. And now I am concatenating colors and color2. In the output cell, you can see a tuple having elements from both tuples. Remember, this is a new tuple and original tuple colors and color2 remain intact. Tuple has two methods, count and index. Now exploring count method of tuple. First, let me define a new tuple, TPL, with its values. Next, finding the count or frequency of an element, say 2 in a tuple, and saving it in a variable x. Now print the variable x and see result. Here it returns 2 as number 2 appears twice in my tuple. Similarly, you can try with other values. Next, we have an index method. Index method is used to access an item at a particular index number. Let's say I want to find the index of value, say 4 here. The output says it is not in the tuple, as 4 is not an element of tuple TPL. Now try same with 2. It returns 1 as element 2 is at index position 1. If we have multiple occurrences of the same element, then it returns the first index position of the element, which is 1 in our case. You can also unpack tuple elements using multiple assignments. Defining a new tuple TPL underscore new with values cat, dog, and fish. Now I am going to unpack the values of the tuple. Here I will use 3 variables to unpack my tuple TPL underscore new. Next, print values of your variables. In the output, you can see X holds first element, Y holds second element, and Z holds the third element of the tuple. Notice number of variables should be equal to number of elements inside a tuple. So in this lab, you learn about tuples and tuples operations that can perform over it and how to unpack values of the tuples. In the next lecture, we will learn and discuss about dictionary data structure. In this lecture, we will explore a new data type in Python, that is dictionary. Dictionary is a collection that is unordered. The values of a dictionary can be any Python data type, so dictionaries are unordered key-value pairs. Dictionaries are changeable, that is, its value can be modified later. Dictionary data structures store value in the key-value pair and they are written within the curly brackets. Instead of indexing, key is used to access the value, just like as you search the meaning of a word by searching that word first. As dictionaries are referenced by key, they have a very fast lookups. As they are primarily used for referencing items by key, they are not sorted. Dictionary does not support duplicate keys. However, more than one value can correspond to a single key using a list. Here is the syntax of declaring a dictionary. The dict variable key value pair separated by a colon is enclosed in curly brackets. Dictionary data structure is not indexed by number. Instead, you have an index of words, and for each word you have a corresponding definition or value. As they are mutable, you can add, remove, and modify values in the dictionary. You can access individual elements using an indexing technique or can iterate through each element using different methods. If you wish to print just keys, you can iterate through dict.key, and for values only uses dict.value method. To access each item one by one with both key and value using method dict.items. A dictionary is an example of a key-value store, also known as mapping in Python. It can be initiated in many ways. For example, you can create an empty dictionary or provide a dictionary with key-value pairs. Let me show both ways to you. Here I am typing D and assigning an empty dictionary to it. The curly braces are a representation of the dictionary. In the next line, I am calling the type function. Now run the code. The output cell shows an empty dictionary with type representing a dictionary. Next, I am going to create a dictionary with key value pairs. Let me call it mobile with keys, brand, model, and price. Now I am going to assign key value pairs to it. The value assigned to the brand is Samsung. See, the key and values are separated with a colon. To another key value pair, we will type model. As both my keys and values are of string data type, so I have enclosed it in double quotes. You can use single quotes as well. And now my last key is price, which holds the integer value 550. Next, we will print this dictionary. And here the output shows a dictionary with key value pairs enclosed in a curly bracket. Values can be assigned and accessed using square brackets instead of indexing. Now let me show you an example of it. Type mobile and pass any key in the square brackets that you wish to access. And here, Samsung is mapped to brand. Similarly, you can also access the model and price. You can assign multiple values in a list to the key. So price is a single key but holding two values using a list sees the square brackets in which numbers are enclosed. Now let's access the key price using the get method. Elements can be accessed using the get method in the dictionary. Now here I have called the get method and the output shows the list of price, that is 550 and 560. You can access elements of dictionary using square brackets as well as the get method. In the next lecture, we will see some more operations related to the dictionary data type. In this lecture, we will practice some more operations related to the dictionary data type. In this lesson, you will learn about how to create, modify, or delete a dictionary and perform operations over it. We will be going through each of the programming example presented here in the Jupyter Notebook. Iterating over a dictionary is very simple using for loop. Here I am using a for loop and then printing both keys and values of my dictionary. Here X is used to print keys and X in square brackets are used to access the value of a key. The same thing can be done by using the items function. This function retrieves keys and values simultaneously from a dictionary. Here I am using two variables in for loop, one for key and the other for value. See the output. You can print either keys or values depending upon your scenario. Values method can be used to iterate over only the values of the dictionary. Then we also have the keys method, which only returns the keys of the dictionary. Let's just implement both the methods here. Firstly, I will implement the values method. And here you can see the result of the values method. Now, copy the same method and paste it here and just change the values method with key method. And here is the result. To check the existence of a key or value, use membership operator in along with calling the appropriate dictionary method. Let me run an example for you. Here the program searches for the brand in the key list of the dictionary. If the key model exists in the mobile dictionary, then it prints, yes, it is one of the keys in the mobile dictionary. Otherwise, it prints the sentence, no, it is not listed in the keys of mobile dictionary. Now let's change the key to color and see the result. Now to find the length of a dictionary, use length method as we used with other variables as well. Here the length of the dictionary is 3 as we have 3 key value pairs. Now to add items into a dictionary, we simply create a new key with a value. My new key is color with the value white. So the new key value pair is added to the list. Now print the entire dictionary to see the result. Now in the result you can see this newly added key value pair in the dictionary. You can also change the value of the key by assigning a new value. For suppose I am changing the value for the key model, and here in the output you can see that the value is changed for the model key. You can also remove the item from the list by passing the key to the pop method. And here I am removing the price from the dictionary using the pop method. Now here you can see that the price key with its value is not in the list anymore. Now to remove the last inserted item, we have a method called pop item. So now I have removed the color key from the dictionary by using pop item method. And here you can see the final dictionary of mobile. Now here in the result you can see the popped item from the list. Let's copy one dictionary into another using the built-in copy method. So here I have declared a new empty dictionary, and now I am going to copy the items of mobile into new dictionary using the copy method. So now here you can see that the same key value pair is copied to the new dictionary we just declared. Now we will try to delete the whole dictionary using the clear method. If you want to clear a dictionary without removing its reference in memory, use a clear method instead of delete method, as it removes the reference of an object from memory too. So now the mobile dictionary is cleared. Here is one more example of storing and printing data for your practice. And here in this example, you can take user input to store values against predefined keys of a dictionary. Here I have created a dictionary with keys, company name, age, and net worth. Notice that here I have not assigned any values to all the keys, because I am going to take user inputs to fill all these values in my dictionary. So to access each key and pass a value to it using the input function, type the company and then assign a value using the input function. Do the same for the remaining two keys as well. Now run the code and pass values one by one. For company name, I'm entering Google, and for age I will enter 22. For network, enter $280 billion. Now print your dictionary to see the result. And here all user inputs are now a part of dictionary users underscore date. So now we are done with the dictionary data type. Next we will discuss about sets, which is another important data type in Python. In the previous lecture we learned how to declare a dictionary in Python. And now we will learn how to implement a set, that is another important Python data structure. Set is an unordered collection of items, which means the item will appear in random order. Unlike a dictionary, set does not allow duplicate values. The values once defined in a set cannot be changed. However, you can add or delete values from it. Elements in a set cannot be accessed using an index but can be printed together or traversed through a loop. Only one type of data can be punched into a set. We will have a look at this concept in the lab session. Now to declare a set, we use curly brackets. Let's declare a set. So now let's move to the lab exercise in the Jupyter Notebook. Here I am declaring a set called languages and assigning different values to it in the curly brackets. Next, I'm going to display it using the print function. And now notice the result shows that C# appears as a second item, although I defined it as my third set element. In sets, you cannot be sure in which order the item will appear. So as sets are unordered, we cannot access items using indexes as we do in the lists. But we can traverse it using a loop. By this time, you are now comfortable with using for loop to iterate through sequences. Type for item in languages. Next, print the items. And here the output cell shows item in a set one by one. In the next lecture, we will learn and practice about the set operations. In this lecture, we will learn how to perform add, remove, update, pop, and some other operations on set. You can add items to set using the add function, or if you want to add multiple items, pass values in an update method. To remove elements, you have various methods, each of them serves a unique purpose. I will show you this using some examples once we get familiarized with the code for a set data structure. Moving to the operations that can be performed on a set, such as add, update, remove, pop, etc. Let's begin from where we have ended in the previous lab session. Remember, once a set is created, you cannot change its items, but you can add new items by using add and update methods. That is, set values are immutable, but the set itself is mutable. The add methods add a given elements to a set. If the element is already present, it does not add any element as duplicates are not allowed in a set. Here I am adding Android as a new element using the add method. Now print languages. Run the code to see the result. Android is now a part of set languages. You can also update a set with any iterable. Let me pass a list of values to the language variable. So here we will type language.update, and here we pass a list of values as an argument. Now print the languages variable. You can see here Go and Java are now added to the set. If you pass a dictionary as an iterable, only keys are stored. So for that, we will write here languages.update, and here we will pass a dictionary to it. Let's say A:1 and B:2. Now print the set languages and see the new values that have been added to the set. Now here notice only the keys are stored in the set. Next, we will find the length of a set by using length method as we did in the earlier lectures. So here it returns 9 as a set consists of 9 elements. Now I will use the membership operator to find the existence of an item. So let's write if go in languages. Let's write a print statement here. Element found in set. So here simply we have just selected go and we have printed our statement. Let's do something else with this. So if we want to delete an element, so we are going to write again, type languages.remove and pass the value here. I'm passing go. So now print the set. So here in the result, you can see the go is now deleted from the list. Python also offers another method to remove an item, that is discarded method. Let's try this method also. So here type language.discard and in arguments pass a. Now print the set to see the changes. You can see that the element is no more a part of the set. The difference between remove and discard is that if an item is not present, discard will not raise an error, whereas remove will raise an error. To make my point clear, let me remove A again using the remove method. So here I'm going to write languages dot remove, and I'm again passing the value A that we have removed earlier by using discard method. So here it raises an error. However, if I use discard method, no error will be raised. The delete keyword will delete the set completely, and clear removes all elements from it as we seen in the earlier lectures. So here I'm going to clear all the elements of a set languages. So for that we will type languages.clear. So now we will print this. Here you can notice all elements are removed from the set languages. If you want to remove memory reference, then use delete languages. Let me call languages again. After deleting the language set. So now here it says languages is not defined as languages can no longer be referenced. In the next lecture, we will see some more operations related to set data structures. In this lecture, we will learn about some more set operations such as union, intersections, and difference operation. Python's set class also represents mathematical notations of a set. Here you can perform set operations like union, intersection, and difference operation over it. This slide is demonstrating an example of union operation between two sets, that is name1 and name2. To perform a union operation, use a pipe symbol or union method. The result will be a set containing values from both sets without any duplication. Sets can't be indexed or sliced. However, Python provides a whole host of operations on set objects that generally mimic the operations that are defined for mathematical sets. Let me give an example of set operations here. Declare two sets, name1 with some values, let's say Pakistan, US, and Australia. And names2 with values UK, UAE, US, and China. Now I'm going to perform union over them. So the union can be performed in two ways, either by using a pipe operator or by using the union method. I will be discussing both of them here. First, type name1 dot union and pass names2 as an argument. In the result, see both the sets are merged together, and here the US appears once in the result as sets elements are unique. And also notice that it returns a new set and both the original sets are in their original state. Now I'm going to perform the union operation on the same sets, but this time using the pipe operator. So type names1 and names2 along with the pipe operator and you get the same result. Both behave identically, but there is a subtle difference between them. When you use the pipe operator, both operands must be set. The union method, on the other hand, will take any iterable as an argument. First, it converts the iterable to a set and then performs the union operation. Let me show you an example here. Type x1 equals 1, 2, and 3. Now I'm going to perform a union operation with set x1 with a tuple having values 4 and 5. run the code. Here it throws an error, and it is written here that unsupported operand type for the union. So here I tried to merge set and tuple together using pipe operator. However, the same thing can be performed successfully using the union method. So for that, type x1.union and pass the tuple to it. And here you can see there is no error occurred and both tuple and set are merged together. Here the union method first converts a tuple into a list and later perform union operations on it. An example of intersection operation between two sets name1 and names2 is demonstrated here in this slide. Now to perform an intersection operation, use the ampersand symbol or intersection method. The result will be a set containing values common in both sets. Here is a difference operation. You can find the values containing the difference between two sets. To perform difference operation, use the minus symbol or difference method. Let me show you intersection and difference operation over sets by demonstrating a simple example. Moving on to intersection and set difference. Intersection returns common elements from two or more sets. Here type names1.intersection and provide names2 as an argument to it. Now run the code. See, in the output cell, it displays the US as it is the only common element present in both the sets. Let's perform the last set operation, that is difference. It returns a set containing the difference between two or more sets. Here I am finding the difference between sets names1 and names2, and in the print function, type names1.difference names2. And here the output cell shows Pakistan and Australia in the result, as both these countries are not a part of set 2 but they are present in set 1. Now do the same operation in reverse order. Copy and paste the cell and edit the values. Now it returns UAE, UK and China as they are not present in names 1 but they are part of names 2. Observe the difference between the two results and learn this operation. So this is it for set and sets operation. In the next lecture, we will learn about importing data sets in Python. In this section, we will see how to import different data files. It can be either Excel file, CSV file, and PDF file. And in this lecture, we will see how to import and write to a CSV file. CSV is a comma-separated file in which each record is represented in a line and fields are separated by a delimiter such as comma. Consider this is as your CSV file with 3 records and 3 fields which you want to import in Python. The CSV module is dedicated to read and write CSV files. This example demonstrates how to open and read a CSV file. Now let's practice in a Python environment. CSV files are compatible with most platforms and easy to work with. The CSV file allows us to put into a plain text file some data values separated by a delimiter, which is usually a comma. This comma is used to separate different fields. However, we can have different delimiters as well, such as tab, semicolon, pipe symbol, etc. They can also be a simplified version of Excel sheets as well. Here I have a sample CSV file. CSV file can be opened by any spreadsheet program. See how the values are stored in it. It is not meant to be read directly. Instead, we can write some program or use some application to extract information from it. We can see here the top line of the file contains the name of the fields, such as first name, last name, age, all separated by a comma. So let's see how it is to read and write values from a CSV file. To do this, we have to import the CSV file module in your program. For that, we have right here import CSV. This module provides the functions reader which work in a sequential manner, and it's a lot easier to read a CSV file instead of doing things from scratch. Now use a context manager with open to read a file and provide two arguments to it. First, pass the name of the files, which is sample.csv, and it is in the same directory in which I'm currently writing this code. And for the second argument, put R there. Use W if you want to write in a file, and to append the file, you can use an A. For both reading and writing, you can use R+. Use any variable to reference it, and here I am using a variable CSV_file. To read this file, use reader method and assign it to any variable. So this is the reader function, and here I am going to declare my variable as CSV_reader. If we just print this variable, here, and we get a memory object. To see what we have in it, we have to iterate through it. So to go through the rows of the files, use a for loop. Let's say for line in CSV_reader, print this variable line, and it will display each row in the output. Notice that each row in the output cell is nothing but a list containing all the fields' value. What we are getting here is the first name as the first element, last name as the second element, and the age as the third element. The very first row in the output represents the field name so that you know the first value corresponds to the first name and so on. If we want to jump over values, such as here, I don't want to display my field name, so I can use a very powerful method, next. Type next and pass CSV_reader to it. Now the list having John Doe 23 is the first result, as you can see here in the output. It prints only the values now, and my field names are not printed in the output. This is how we can read CSV files in Python. Similarly, you can write data into your CSV file. And to write data in a file, use method open, provide file name, and then provide W after comma as we are writing to this file. Now use CSV method writer to write data in your CSV file. Now let's practice this example in Jupyter Notebook. So let's see how we can write to a CSV file using the same CSV module. First, define your list of data. This is my data that I want to be written to a CSV file. Now using the context manager, open an empty file in writing mode. Let's say my file name will be myfile.csv. Next, use CSV method writer to write these values in your CSV file. Type csv.writer and pass the file reference to it. You can also provide a delimiter to it. I am using a semicolon as a delimiter. The default is comma, that is, if you don't set a delimiter, comma will be used. Next, use write rows method. Type csv_writer dot write rows and pass my data to it. Now print a line in the end which says file has been written successfully. Now execute the code and you can see your file is saved. Let me open the file. So this is my file and these are the values. Notice the rows are separated by 2 new lines instead of 1. We can remove these additional blank lines. Let me show you how to do it. Pass another parameter, line terminator, in the writer method and pass \n to it, which is an escape sequence to print a single new line. Now change the name of file or overwrite the existing file. Here I am giving it a new name, say my file2. Run the code. Now open the file and see now 2 rows are separated by a single line only. So this was a brief yet concise discussion on how to load and parse CSV files in a Python program. In the next lecture, we will discuss about importing data from Excel file. In this lecture, we will discuss and practice about importing data from an Excel file. To import data from an Excel file, you have to install the relevant package. In future module, you will learn about packages and how to install a package. But for now, this command in Anaconda command prompt, pip install xlrd, this will install the necessary package. Type import xlrd to read an Excel file. Give the file path, open the workbook, then provide sheet number and cell value to read data from it. Let's perform some code in the Jupyter Notebook. To import data from Excel in Python, we have to install xlrd module. And if you are going to use this module for the first time, you may need to install it first. Let me show you how to do this. Open Anaconda prompt. Now type pip install xlrd. It will install this library. As I already have this library, therefore the command prompt says the requirements are already satisfied. Otherwise, it will fetch the library for you. Now import xlrd in your program. First, we have to import xlrd module to read Excel file. Here I have opened an already present Excel workbook for you so that you can see the data values. So here first we will open the Excel workbook that is passed using the open underscore workbook method. An Excel workbook can have multiple sheets. First, I'm going to find out how many worksheets there are in the workbook. So we write this method and sheets and it says 2. Next, I print out their names. So here, this method will display a list of sheets name present in my Excel workbook, that is schedule and names. Now to access the sheet of an Excel workbook, pass the index number of your sheet to the method sheet underscore by underscore index. Pass 0 to access the first sheet. So here I have counted the number of rows present in a sheet, and here in the output cell it says 11. Next we find the number of columns, so for that we typed first sheet.endCalls and it says 5, as I have 11 rows and 5 columns in the worksheet schedule. So now to extract a particular raw value, so here I will type first sheet dot raw underscore values and pass value, let's say 1 here. The output cell returns the second row of the sheet. Here indexing starts from 0 here, so to access all rows of your workbook, use a loop. Type for I in range first sheet dot end rows. Now print the rows values as we did earlier, but this time instead of a hard code value, pass the looping variable as a parameter. Now run the code and it returns all 11 rows in the output cell. You can also access a particular cell of an Excel sheet. So for that, type first sheet dot cell underscore value. Suppose I wish to access this cell, semester 1-B. Semester 1-B is the data value present in the second row of the first column. So we pass 2, 1 here and it returns semester 1-B. This is how you can access and import Excel's data in the Python. In the next lecture, we will see how to import data from a PDF file. In this lecture, we will learn and practice how to import data from a PDF file. There are many libraries available in Python to read PDF document, such as PDFmine, PyPDF2, Tabula-Py, Slate, PDFQuery, and XPDF. Now I will install PyPDF2 for importing the PDF document. This is an example to access PDF data. Let me demonstrate this in the Jupyter Notebook. We will be using a third-party module, that is PyPDF2, to import data from PDF file. It is capable of extracting document information, splitting and merging documents page by page, and much more. First, install it from Anaconda command prompt using command pip install pypdf2. As I have already installed it, I am importing it here directly. Now type import pypdf2. Next, open your PDF file using the open function with read binary mode. Here we will give our file name. So here my PDF file name is svm.pdf. Let me create a PDF reader object, let's say PDF reader, using the PDF file reader method from the imported library. So here I have typed pypdf2.pdf file reader, and here I'm passing the file object to it as an argument. So this is how you can get access to a PDF file. You can fetch and print the total count of pages in a PDF using numPages property. So for that, type PDF reader dot numPages. So it returns 26. That means we have 26 pages in our PDF file. As you can see, we get the number of pages in the code execution. Similarly, there are many other features as well for the file reading in Python. Like if you want to extract the text out of any page, you first make a variable, as can be seen here with the name page. Here we have saved page number 3 in the variable page using the command getPage bracket 3. And in the next line we have printed the page using the print command. I will leave this part as a practice for you. The code used for this is also available in our Git account mentioned in the resources section. So in this section you learned about different ways of importing datasets and also the functions related to the imported modules. And in the next coming lectures we will learn about defining the functions in Python. In this section we will learn about the functions in Python. Python has a vast library of system-defined functions. We have also used some of the built-in functions in our previous lab sessions. And we will also learn how we can make and use our own functions in our code. In this lecture, we will learn some built-in functions available in Python to ease our tasks. Built-in functions are also called as system-defined functions. Python library has a rich set of system-defined functions, and in the next slides, I will show you a list of some common functions that we use in our code. Each of these built-in functions perform a specific task. The code that accomplishes the task is defined somewhere, but you don't need to know where or even how the code works. All you need to know about is the function's name, its required parameters, what values it returns. You call the function and pass the appropriate arguments, then program executes, and program execution goes off to the designated body of the code and does its useful thing. When the function is finished, execution returns to your code where it left off. Python library has a rich set of built-in functions ready to be used, and here is a list of some of the built-in functions and its description. Now let's open the Jupyter Notebook to practice some of these built-in functions. Python provides numerous built-in functions to help ease your task. So let's talk about some of them here. If you are a regular computer user, you have used the .zip file extension. Do you know what it is? Basically, .zip is a container itself which holds the real file inside. Similarly, Python zip is a container that holds real data inside. This function takes iterables that can be 0 or more, aggregates them in a tuple, and return a zip object, which is an iterator of tuples where the first item in each past iterator is paired together, and then the second item, and so on. Here I am defining 3 lists: student name, roll number, and marks. I want to aggregate them together, so let me use the zip method for that. Type an identifier, say mapped, and now zip your values together that are student names, roll number, and marks. Now print this variable. Here it returns a zip memory object. Next, you can use the already known function type to check the data type of this variable mapped. Here this function returns the type of the object as expected, which is a zip object. Now let me convert the zipped values in a list so as to print them using the built-in list method. Now here type record equals to the list, and pass your zipped value mapped to it. Now print the list record, and after executing your code, you can see the result. It displays Sarah, 4 and 90. Here each item of an iterable is paired together and a tuple is formed. Such as item from the first Sarah is aggregated with the first item of roll number and marks. In this way, a tuple is formed. As we have 4 items in the list, we have 4 tuples in the output. Let's suppose 2 iterables are passed to the zip method, one iterable containing 3 and the other containing 5 elements. Then the returned iterator will contain 3 tuples. It's because the iterator stops when the shortest iterable is exhausted. If we do not pass any parameter, the zip method returns an empty iterator. Now let me do some quick code here using the Python system-defined functions. You have already learned some of these functions in section 4. Now let's explore some other functions using the advanced data types such as a list. As I have already defined a list of marks having numeric values, now I'm going to add the elements using the sum function. Let's say total marks equals to the sum, which is a built-in Python function, and pass marks to it. Now print the marks and run the code. Here the output cell shows a single value 300, which is the sum of list elements. Let me sort the marks in ascending order using sorted function. Now the list is rearranged in the output cell starting from the lowest value. Next, I'm using the map function, which takes 2 input parameters. First, let me tell you about the map function. It takes a function and a collection of items. It makes a new empty collection, runs the function on each item in the original collection, and insert each return value into the new collection. Now let me tell you about this function using a simple code so you will get a better idea of it. Now here, define a list of names with some values, let's say Isadora, Bob, and April. Now I am going to pass this list and calculate the length of each item using a predefined function that is length already familiar to you. Now type names underscore length equals to the map, and we are going to pass here length as the first argument. You can pass any user-defined function here as well. Next, in the second argument, pass the list of names. However, any iterable can be passed here. Next, print the identifier names underscore length. And here you can see that the result shows a map object, but it is not readable. Now you can convert the result into a list or set and then print the result. So type print list and pass names underscore length. So this is a simple map that takes a list of names and returns a list of the lengths of those names. Finally, when we convert this map result into a list, it displays the result. The output cell here shows that Isadora has 7 characters, Bob has 3, and April has a length of 5 letters in their name. So here we learned 2 methods, map and zip, and also we learned converting their values into a list. Now this is it for this lecture, and in the next lecture we will learn and practice some more built-in functions in Python. In this lecture we will start from where we left in the last lecture, and now we will open the same notebook and start practicing some more built-in functions in Python. Now let's convert a list of tuples into a dictionary using the dict function. Here I have defined a list of tuples. Now I'm going to convert it into a dictionary using the dict method. So here I will type my dict equals dict and I pass my list to it. Now print this variable, run the code and see the result. Each tuple of the list is converted into a key value pair. Here the first item becomes the key and the second item becomes its values. Also, you can convert a list into a tuple. Here is a list of words. Let's convert it into a tuple. So type my tuple equals tuple and pass the name of the list, which is new underscore list. This function converts this list into a tuple. Now print your tuple and execute your code. So here in the result, you get a tuple. Similarly, a tuple can be converted into a set. Now type set and pass this to tuple. Here it returns a set. Next, we have a dir method. You can find the valid functions and properties associated with an object using dir method. Let me type print dir and pass the name of your dictionary, let's say my dict, to it. It represents all the valid dictionary functions such as length, items, keys, pop, etc. And you are also familiar with all these methods. Similarly, you can find any other object here to find its valid attributes. Next, we have method help, which guides on usage of any method. So here I want to find the usage of print method. So this is the help of this print method. The output cell shows the detail with definition, that is, print the value to a stream or to system standard output by default, and here are optional keywords that can be passed to it. If you do not know the usage of a function, there is a function that can assist you. What if you passed a variable name and some integer in a quotation, that is a string, and you want it to be evaluated as numbers? For this case, Python offers a very interesting function, eval. Eval parses the expression passed to it in quotations. Now let me run an example. We have operand equals 11. Here operand is a numeric variable and in expression I want to add 1 to it. Here the output cell returns 12, which is the sum of operand and 1. Due to the eval method, operand is replaced by 11 and 1 is added to it. So if I don't use eval here, it returns a string in output which says operand plus 1. So this is how eval is useful if you want to evaluate from a string. Next, we can find the maximum and minimum from any iterable. Let me apply this on list of strings and integers for you. So here I have defined a list of companies and a list of marks. Now I'm going to find maximum value from both these lists. First, I apply max on companies and later on marks. Now run the code and see the result. It says IBM and 100. So if the item is an iterable are strings, the largest item ordered alphabetically is returned. Here, according to the alphabetical order, IBM is returned in the result cell as I comes after G, A, and C. And of course, 100 is also the maximum number in the list marks. Similarly, you can find a minimum item from both these lists. So let's print the minimum values. As expected, 10 is the minimum number, and Apple from the list companies, as A is the first element when sorted alphabetically. So this is returned as minimum value from the iterable companies. Moving on to the next method, that is CHR. This method takes a single parameter, an integer having a range from 0 to this number. So let me use it. Let's type print CHR and pass 97 to it. Here it returns a corresponding character defined in the ASCII system, which is a lowercase a here. Now try for some other values by yourself. Now we have ID method, which returns the identity of an object passed to it. Here I passed an integer variable to it, and it shows its corresponding identity used by Python. The identity is unique and constant for this object during its lifetime. Next, I will explain the slice function, and it is very useful when dealing with iterables. Here I am slicing a list. The function can take up to 3 parameters: start, stop, and step. But they are optional except stop. Let me show you how to use it. So using the same list of companies, now I want to get a slice of 3 elements from the starting index. So I typed slice 3, and I have assigned it to a variable slice underscore val here. 3 means my stop will be at index 2. Now print the slice method here. So here, after running the code, you can see the result. It returns IBM, Google, and Apple. Remember that the slicing stops at the index before the stopping value. As you see the element at index 3, Cisco is not included. And since we only provide a stop value, starting index is 0, so in this way we get 3 values out of it. Let me tweak it a bit. Now I'm going to set my start and stop with it. Means I want to start at index 1 and stops at 3. So after running, it returns Google and Apple. It starts from index 1 and ends at index 2. Let me pass a step value to it, which is a set to none, in case we don't provide it explicitly. Now see, we only get Google here, return skipping Apple. You can give 4 as a stop value and run the code. Now Google and Cisco are returned skipping Apple. So this is how slice function works. You can use it to get substring, sublist, subtuple, etc. So this is the end of this lab session, and I hope you get a better idea of how to use built-in functions in your code with advanced data types. And in the next lecture, we will create our own functions to perform some programming tasks. In the previous lecture, we learned about the built-in functions in Python. And in this lecture, you will learn how to define your own Python functions. A function is a self-contained block of code that comprises a specific task or a related group of tasks. The idea is to use existing logic in your program repeatedly without typing each line again and again. It will not be executed unless called in a program explicitly. It is also called as a method or procedure. So to define a function in Python, we use the def keyword followed by a valid function name. The return statement is used to exit a function and go back to the point from where it was called and assign single or multiple values returned from the function and store the returned value in a variable. Let's look at function definition closely. Start a function definition using the def keyword and then give a valid name to your function. Next, you need a pair of matching parentheses, and inside parentheses you can pass optional arguments. After closing the parentheses, provide a colon, which is mandatory. Arguments are input data to the function. Next, write one or more statements as your function body with indentation, just like you did earlier in conditional statements and loops. When you will call your Python function, the program execution will transfer to the body of the code that makes up the function, and the code inside the function body will get executed. And after the end of the function, control is transferred back to the line from where the function call was initiated. Now let me give you an example of a user-defined function in the Jupyter Notebook. So let me give you an example of how to create your own function. So on the top of the line, I'm putting a comment which says this is a function to print hello. Now I'm typing a function definition and it has to start with def keyword followed by a function name, and you can give any valid name to your function here. I'm giving it name my underscore function. And next, type a pair of matching parentheses with 0 input parameter. After closing the parentheses, provide a colon as it is mandatory. The body of the function consists of one or more statements and all of them should be indented. So in the body, I'm just giving a print statement with a sentence hello from a function. Now run your code. As you can see that nothing happens. It is because you have a function but you never call it. So what you have to do, you have to call it. So here I will call it by typing its name, my underscore function, followed by a pair of parentheses with 0 arguments. So this is basically you are asking the Python interpreter to go and call the function. Now, after running this, you get the result here. Hello, friends. You can call this function as many times as you like. You can even call it inside a loop to execute for a particular number of times. Now, let me show you an example. Type for x in range 5, and in the body, call your function once. Now run the code. You can see here it calls my function 5 times. This is how function is created and executed. Now let's pass some data to our function here. I have declared a list of fruits, and now I'm passing this list to my function where each element of the list is accessed using a for loop as discussed in the earlier sections. And when I call my function, I will get the results on my screen. Let's perform a small example of a function with an argument in the Jupyter Notebook. So let me do some modification. I'm copying this code and pasting it here. Let's give a new name to the function, so new underscore function, remove the word friends from the print statement. Pass an argument to the function. Okay, so I have modified the function such that whatever you give it as an input stream, it will take that input string and print it after the hello world. So run the code and the function is created. Now I will call the function and give it input argument Sarah. So you can see it says hello Sarah. Of course, you can pass any input string, or you can use the input method to take user input at runtime. So let me show you this example. Here I am using the input method. Now call the function and pass the value to it. Run the code and it asks for a name. So I enter here Farheen. It says, hello Farheen. Now if we pass two input strings to it and expect it to run for two different results, it will throw an error as this is incorrect. So let me show you this example. Now here pass two values to your function. Let's say ABC and XYZ. Now run the code. And here it throws an error as your function definition requires only one input argument. So in this lecture, we learned how to define a function and call the function with and without passing the arguments to it. In the next lecture, we will learn more about function arguments in Python. In the last lecture, we learned about the function definition and calling the function with arguments. And in this lecture, we will learn about default arguments, keyword arguments, and also passing arguments by reference. What if the user forget to pass an argument or you want a default value to be set in your function? For such scenarios, you can pass a default argument in parentheses. As you can see here, the function takes the country equals Norway as the default value. And the purpose of this function is to print the nationality of the user. When you call this function and supply a string to it, it will substitute that string in a variable country. However, if you fail to provide an argument, as in the case of the third function call, Norway will remain set as the country and output will be I am from Norway. If you open Python documentation for functions, you will notice word quarks. No need to worry, it is just a short form of keyword arguments. Let's have hands defining a function with the default and keyword arguments. Now I am creating a function with a default argument. First, define the function and provide the default value by setting value Norway using the assignment operator. And in the body of the function type, I am from and pass the keyword argument country to it. Let me call it first with a value, let's say US. And here it says I'm from US. Next, I'm calling the same function without arguments. It says I'm from Norway, which is my default argument. That is, in case you do not pass any argument to the function, it will print the default value. Let me create another function with keyword arguments. First, define a function. Type def myfunction2, pass two keyword arguments, let's say language and message. In the body of the function, print it is fun to learn and join the keyword argument language and continuing the expression type and followed by concatenating it to the second keyword argument. On calling the function, pass two keyword arguments, say Python, and in the message type, I am going to master it. Now run the code and it says it's fun to learn Python and I'm going to master it. So you can play around with them by switching the position of keyword arguments. See here. Now it returns a sentence with a different arrangement. Let me restore it back to its original position. You can use one or both arguments later in your function body. It is not necessary to use all arguments. So here I have removed message from the print statement. Now run the code and see the result. Now message is not displayed. This is how you work with arguments in function. You can use functions to manipulate advanced data types as well. In Python, arguments are passed by reference. It means if you change what a parameter refers to within a function, the change also reflects back in the original variable or data structures. Python uses a mechanism which is known as call by object, sometimes also called call by object reference or call by sharing. If you pass immutable arguments like integer, strings, or tuples to a function, the passing act like call by value. It's different if we pass mutable arguments. All parameters in the Python language are passed by reference. Both the functions and the caller refer to the same object in the memory. It means if you change what a parameter refers to within a function, the change also reflects back in the calling function. So using the same example as discussed in the slide, now here we create a function, example, and pass argument z to it. The role of the function is to append the incoming data within a value 20. So before calling this function, first create a list A with value 10. Here the print statement is going to show the value of A before calling the function. Now call the function which will append the list. Next, type another print statement which says the value of A after calling the function. Value of A changes and 20 is appended to it. Since list is a mutable data type, it is passed by reference to the function. However, integer, string, tuple, and others immutable data types are passed as a value to the function. Let me show you an example. Here I have defined a tuple B with value 10. Now copy the values from the cell, paste it here, and do the modifications such as replace A with B. Now run the code and see the value of B remains unchanged as B is a tuple. This is how Python works. It uses a mechanism of the call by object. In the next lecture, we will learn and practice about the return statements in Python. In this lecture, we will learn about the return statement in Python. If you want to perform some computations or logical operations inside a function and do not want to print the result there, rather want the results for some further computations, or you want to store results in some variable outside the function, you can use the return statement for that. So remember, return statement can pass single or multiple values. Its default value is null. Here we defined a function named square that takes an input from the caller and sends back its result to the calling program using the return keyword. Let me show you this example in the Jupyter Notebook. Let me implement the function of calculating square of a number, and instead of printing in the function, I will return the result back to the user using the keyword return. So type def square, use the return keyword to pass the result back to the caller. Multiply number with itself. Now call the function and here pass the value, let's say 3, and save it in a variable result. Now print the square of a number and run the code. It says the square of a number is 9 in the output. This is how it works. The function performs the calculation, and instead of printing the result, it is sent back to the caller. Now in Python, you can return multiple values from a function as well. So let me create a function that calculates the square and cube of a number and return both values that are return statement with multiple values. So I have copied the above code and pasted here. Now let me redefine it and do some modifications for calculating the cube of a number. Now it will return both the values. Now let's call the function with a number, let's say 2, and as the function is returning two values, so we are using two variables to hold it during assignment operation. The first is sq and the second variable cube, and we have passed 2 value to it. Now display both values in a print statement and run the code. So here it displays that the square of number 2 is 4 and the cube is 8. Sometimes we do not know in advance the number of arguments that will be passed into a function. So Python allows us to handle the kind of situations through function calls with an arbitrary number of arguments. Let's see how to do this. Here I have defined a method to greet a number of users, and in parentheses type static names. Static is the representation of an arbitrary number of arguments. Next, as I have no idea how many arguments the function is going to take, I am using a loop to iterate through all arguments. So type for I in names, as names can be single variable or a list of any iterables. And in a print statement, I am going to greet the user. So type hello and a looping variable. Now call the function greet and pass multiple values to it. Let's say Sarah, Francis and Bob. Run the code and see the result. Okay, the names of my function is greeting and not greetings. So here it says hello Sarah, Francis and Bob. This is how you can pass arbitrary arguments to your function. You can pass a list here too. So let me give you a quick recap of what happened here. These arguments get wrapped up into a tuple before being passed into the function. So inside the function, we use a for loop to retrieve all the arguments back. Let's do some more example on functions. Here I have created a very interesting function for you as we have reached the end of the module. So this function asks the user to guess the lucky number. The name of this function is lucky num. I have set lucky number to 10 and initialize a variable number to 0. The function takes user input and searches if the number is the lucky number or not. So if yes, the user wins, otherwise it again asks for a number and keeps checking. All is done using a loop and a conditional if-else in the function. So now let me break this down a bit. Now here in the while loop, I placed a condition which evaluates if the number does not equal to the lucky number. Next, in the body of the loop, I asked for user input, and after converting it to integer, I stored the value into a number. In the if condition, I equate the number entered by the user with the lucky number. If it evaluates to true, the user will win. Otherwise, control transfer to else block, which says sorry, incorrect, and try again. So run the code to make things clear to you. So call lucky number and run the code, and it asks for a number. So I type 5 and press enter. It says sorry, incorrect, try again. Now it again asks for a number. Let's say I type 7 Again, it's incorrect as 7 is not equal to 10. Again, the loop keeps on repeating until I enter the correct number, which is 10, and then it says, you guessed it correctly. So try to make some changes in it, like for example, you can give users 3 chances to guess the lucky number only. In the next example, I'm going to use a dictionary, functions, and loop together in a function. Now here in this function, I'm going to calculate the billing invoice, and here I declared a variable billing amount and sets its value to 0, and the function takes one argument called data. Next, the loop iterate over its value. In the loop, the billing amount is calculated by adding looping variable I to it. So let's see what I is going to be. The user order is going to be a dictionary of items and their values. Next, call the function and later save its value to a variable called total. Pass argument order to it. The loop inside iterate on these values. So I will hold the price of the food items, and these prices are summed up together into a billing amount. The later function returns its billing amount, which is saved in total. Next, print the total amount. So after running the code, it says your billing amount is $227. So in this lecture, you learned how to create user-defined functions and use loops, conditional statements, and simple calculation inside them. In this section, we will learn and practice about the Python module, Python packages, and about the import statements in Python. And in this lecture, we will be practicing the use of Python modules. Now you already know about Python functions. It is time to get familiar with modules. The objective of this session is to teach you Python modules. A module is a file consisting of Python functions, objects, and classes. It helps you to organize your code as it groups related code into a single file, which makes it easier to understand and use. The module name is the same as the name of Python file. So why do we need a module? When we want to perform the same type of task in multiple programs without writing the function every time. Python has a number of built-in modules for performing tasks related to data types, numeric and mathematical modules. To access files and directories, we have different predefined modules, data compression and archiving modules, and for numerous other applications as well. Let's code few of them in our Jupyter Notebook. Let me show you some examples of using built-in Python modules. Practice along with me to get a deeper understanding of all the modules. Here I am going to type import math as m. So basically I'm importing maths module here. This module provides access to the mathematical functions. And here first I am calling py functions from the maths module. So print m.py and see the result, it's 3.145. You can find Euler's number, which is the base of the natural logarithm, which is 2.718. And to find the hypotenuse, use hypot and provide 2 input parameters to it. So here type hypot and provide 2 values, let's say 3, 2. It returns Euclidean norm. The built-in double asterisk operator comes in handy, but if performance is of the essence, use math.power. So be sure to note that however that power returns float even if the arguments are integer. So let's find the power of a number. So here I have typed m.power, pass 2 values, say let's say 2, 3, and it returns a floating point that is 8. We can also find square root of a number. So for that, type m.square and pass 4 to it. Now run the code. It returns 2 as 2 is the square root of 4. Next, we can find ceil and floor values of a number using this module. Suppose the value of a number is 3.678, and now I'm going to pass ceil and floor value of it. And now print m.floor and pass the value here. Run the code and see the result. The ceil returns the upper bound, whereas floor returns lower integral number. You can also find logarithm of a number, as we know that the log of 1 is 0. So we will write here in the print function m.log of 1, and that is 0. Next, we'll find the exponent of a number. So type exp and pass 1 to it. And here it gives Euler's number. Now let us move to the trigonometric functions. We have radians that can convert degree into radians. So I will use the radian function here. So type m.radians, pass any value to it. Let's say we pass 30 here. Let's see what it returns. So it returns 0.523. You can also find degrees by using the degree function. Now type in the print function m.degree. Now pass 0.52 here. And we get 29.79, that is close enough to 30. Now I'm going to find sine, cosine and tangent values. All results of the trigonometric functions return the result in the radian. So you may need to convert it back to degrees. So let's find trigonometric ratios for the angle of 30 degrees. So this is the sine value. This is the sine function, and here it is the sine value of angle 30. Now let's change and find the cosine value, and here you can see in the result. And lastly here I'm finding tangent of it. So similarly you can also find inverse trigonometric values as well. Let me do one for you. Let's suppose I want to find out arc sine of 30 degrees. So this is the result. And in the same way you can find arc cosine and arc tangent values. Now let's call hyperbolic functions of trigonometry. Type a sine h, and here is the value. And it returns 11.548. Similarly, you can find other hyperbolic values as well. Now let's move to the system module. So type import system. To find your path, type system.path and execute it. Now it will show you your current working directory followed by directories listed in your Python path environment variable, followed by installation dependent default paths, which are controlled by the site module. Now to display the Python interpreter current version, type system.version. Run the code, and in the output, you can see the Python version that we are using right now. Now let's move to the OS module. The OS module in Python provides function for interacting with the operating system. It provides a portable way of using operating system dependent functionality. So to create a new directory, use the mkdir function from the OS module. Here I have typed mkdir and provide a path and new directory name. Now run the code, and here it will result in a new folder called demo created in my D drive. See here, a new folder with the name demo is created, and right now it's empty. So now let's move to the stats module. Let me perform some statistical functions quickly. For this, type import statistics as st. It will load all statistical functions provided by the library. Now I'm going to find the mean of numbers. So print st.mean and pass values, let's say 2, 3, 5, and 10. Run the code, and here it returns 5. As mean is the average of numbers, that is the sum of all numbers divided by the count of total numbers. Next, I'm going to find median of the list. Copy the code, paste it here, and here we will change the function name. Now run the code, and it gives you the median value. Next, we will find the mode value. So for that, I will use same list but repeating 2's in the list. As we know that the mod returns most frequent values. So here it is, 2 is the answer. Now let's find standard deviation, and for that type st.stdev, that is a standard deviation function. Standard deviation is a quantity expressing by how much the members of a group differ from the mean value for the group. So here is the result of the standard deviation function. Now find the variance, copy the code and paste it here, change the method name, run the code, and it returned 10. In the end, let's see an example of data compression and archiving modules. It is also an important module for advanced purposes. Here I am importing it to just check whether the list of files are zipped file or not. So using the function is_zip file from the module, and using membership operator, we will iterate over a list of files using for loop, and we'll find whether the file is an archive file or not. So here let's write the code for this. nb1.csv example.zip. Now run the code, and it says nb1.csv is not a zip file. As you can see that it is false here. Example.zip it is a zip file. ex2.zip is a zip file, and .zip not found in my directory, so it returns false. So these are some of the examples of modules and their usage. In the next lecture, you will learn how to create modules in Python. In this lecture, we will see how to create modules in Python. Recall user-defined functions. We have user-defined functions, but their lifetime is determined by the program. That is, it can be used in that program only. So what if I want to use the same logical unit in some other programs? Creating a module is very simple. You can save your function in a separate .py file and import it for later use. You can define as many functions and classes in a module as your problem scenario demands. So creating modules enable code reusability. I will explain how to create a module in lab later on. Just hang on a while. Here we have created a module named my_module and saved it using .py extension. In this module, I have defined two functions. First function is greeting, which expect a string input to it. And the second function is performing addition on three numbers. So let's create and save a module in Python. Suppose you have written some functions that you intend to use later, so you can create a module in that case. Now here let me create a module for you. Here let me add two functions that we did earlier in our previous sections. The first function is used to greet user. Now here let me change the name. And this is the second function to calculate the square and cube of a number. Now I am saving it as .py file. Press file and then from download choose .py and giving it my name as my_module. Now save this file. So the question is how to access and run this module. So in the next lecture, we will see how to import this module in Python. In this lecture, we will see how to import the module that we created in the last lecture, and we will also discuss use of a module alias and from keyword. Once a module has been created, you can use the import statement to call your module and associated functions in your program. Let me demonstrate how to use import statement. Remember, in the last session, we created a module with two functions, greet and add. Now we are going to call them in our program. First, import your module, my_module. Next, call method after adding prefix of your module, name followed by a dot. Let's import our module and execute methods in it in Python. As our module my_module is ready, next we have to import it in our program, just like the math or any other built-in module we did in the previous section. Type import my_module so that you can load this particular module here. You can use all the functions of your module, but how to access them? Suppose if I type greet here, the first function of my module, later in parentheses I passed value Danny. So we get an error, and the reason for getting this error is that I did not explicitly tell where to find this function. Now when I type my_module followed by a dot and then call this method greet, now let's run this code and it shows me hello Danny. Similarly, we can call the second function my_module dot this. Here I'm copying this and pasting it here. And with 3 as an input parameter to it. See, when I call my second function with input values 3, it gives me 9, the square of the number, and 27, which is the cube of it. Since we used return keyword in the function, the result is returned in a tuple. You can fetch the result in variables too, like x, y. Copy the code and paste it here. And then write a formatted print statement. It says the square of the number is this and cube of it is this. Next, pass your variable as arguments in the format method. Now run the code and it says the square of number is 9 and the cube of it is 27. We can use dir method to find function names that are defined inside a module. So type dir and pass the name of your module in the parentheses. Here you can see that we have greet and underscore sq cube in it. Remember, the user-defined functions are represented without an initial underscore. Also, modules once imported need not to be imported again. To avoid calling long module names, you can give them aliasing. Aliasing is just like a nickname you give to a person instead of calling his actual name. To import only specific functions from a module, you can use from import combination. Like type from keyword, then module name followed by import statement, and then type method name from the module. Let's perform this in Python. So open your Jupyter Notebook. Let me tell you about aliasing a module. I have created a module num_module for this topic. So type import and name of your module, and after as give an alias, say nm here. This is my module that I have created. Now find the associated functions of the module using dir function. Type the name of the modules in dir method. Now here we have tbl and square as functions defined by user. Let me open this module for you so that you can see the functions and the required arguments. Here we have a function called square that returns the square of a number, and another function tuple which prints the multiplication table of a number. Now let's get back to the program. To call tbl function instead of writing complete module name, use aliasing. So type nm.tbl and pass an integer, let's say 5 to it, so it returns the multiplication table of 5. You can just import part of a module. That is, you don't want to import all functions of a module. So for this particular, I have another module, my module 2. It has 2 functions. Suppose I only want to use function 2 in my program. So now how to do this? In that case, let's write here from my underscore module 2 followed by a white space and import function 2. Now only this function is imported from the module. Now call this function directly. Here type function 2 and pass any value to it, let's say 10. So the output is displayed once you run the code. But what if I type function 1 and run the program? Now here it throws an error message, function 1 is not defined. Means this only function 2 of module is imported here. So this is how it works. You also import all objects from a module using from import as static combination. But I will recommend not to load all the functions of a module if you need a few functions from that module. Loading all the functions and objects from a module will load additional or unnecessary objects into your memory. So in this lesson, you learned how to import module in a variety of ways, and in the next lecture, we will see how to locate a module in a Python. In this lecture, you will get an idea of how module is located in Python. When you import a module, the Python interpreter searches for the module. First, it looks in the current directory. If the module is not found, Python then searches each directory in the shell variable Python path. If all else fails, Python checks the default path. The module search path is stored in the system module sys as the sys.path variable. The sys.path variable contains the current directory, Python path, and the installation dependent default. In this lecture, you learned how Python identifies a module, and in the next lecture, you will learn about packages in Python. In this lecture, you will learn about packages and what is pip package manager in Python. Packages are namespaces and collection of multiple subpackages and modules. They are simply directories. You are using a computer, but do you save all your tasks in one location? No, you organize them in multiple folders. Folders or directories are analogous to packages, and files are analogous to modules. A directory must contain a file named _init_.py in order for Python to consider it as a package. This file can be left empty, but we generally place the initialization code for that package in this file. Here is the pictorial representation of a package. You can see the hierarchy of how subpackages and modules are defined in a single package. A package is just like an operating system directory that contains files. A package can have more than one modules, and modules have functions, classes, or variables in it. Pip is the standard package manager for Python. We can use pip to install additional packages that are not available in the Python standard library or update current packages. For example, to check version of Python, open command prompt and type pip --version. It will show you the version number of Python installed in your PC. Let's try this out. So open Anaconda command prompt. Now here type pip --version and press enter. Now it will show you the latest version number of pip command installed in your PC. You can also install a package, for example, pip install numpy. This command will install the numpy library. Similarly, you can uninstall a package or library using pip uninstall. So let's try this in Anaconda command prompt. You can install packages from Python using pip command. So here we have opened our Anaconda command prompt, and I am installing a third-party package called requests here. So I have typed pip install requests, hit enter. The package will start installing. So you only need an active internet connection. See, it says requests is successfully installed and the version of package is 2.23. This package is used to send HTTP requests to the server. Now let me uninstall a package. Type pip uninstall and then package name requests. You can pass multiple packages names and all separated by a single white space. Next, it asks for your consent before uninstalling it. Type Y to proceed. And see, the package is uninstalled now. In this way, packages can be installed and removed in Python. So in this lecture, you learned about the packages in Python and also how to install or remove a package or library in Python. So you have reached the end of your Python journey. We taught you all the fundamental Python concepts that will help you land your first Python job quickly. In the last module, we will take you around the world tour of Python to give you insights of Python world. We will see who is using Python, why is Python being used extensively, applications of Python, and much more. So let's move. Here are some of the Python job profiles. Every job profile has different title, different perks, and different nature of tasks. We have listed the set of activities that each role performs. Take your time and read the job description of every role listed and decide your role where you want to land in next 5 years by using Python. Here we discuss some of the major computer science domains that are heavily dependent on Python. The one big domain is big data. Python has deep roots in big data, AI, machine learning, data science, and fields that are concerned with business intelligence. So you can see the bunch of libraries that are specifically designed for playing with companies' data and unleashing the insights from the data. The networking world is immensely using the Python for the automation and management of network hardware and network software. Cisco is investing so much time and money researching how to use Python for automating switches, routers, and other core networking devices. And Cisco is getting successful in that. A brand new domain, Internet of Things, utilizing the Python to empower the power-hungry and slow-speed sensor-enabled devices to perform efficiently for a longer period of time. As we discussed earlier, Python is the ultimate demand for the AI world. Tools used artificial intelligence and its subfields are powered by Python. Tools used for artificial intelligence and its subfields are powered by Python. Unlike other conventional programming languages, Python is very easy to integrate with artificial intelligence libraries like TensorFlow, PyTorch, and so on. And in the end, we want to share earnings of different Python-enabled job roles. As you can see, a less experienced software engineer can make more than 1 lakh USD per year. So don't wait, jump deep into the Python world after finishing this course. If you like this course on Python fundamentals, then sign up in the next course, that is data analysis with Python. Okay students, thanks for your patience and support throughout this course. We wish you success in every walk of life. This is a bonus section on the topic for exception handling, and in this lecture you will learn how to avoid crashing your Python code. Any machine built by human beings can have errors and faults. In the same manner, any code written by human beings can have bugs or errors. Bugs or errors are defects in your code that prevent your program from completing its task successfully, and most of the times your program crashed unexpectedly due to that bug or error. So being a software developer, you need to spot that error and then catch that error. So here comes exception handling into the play. Before we get into why exception handling and what are its details, first let me tell you that there is a subtle difference between errors and exceptions. Errors cannot be handled, while Python exceptions can be handled at the runtime. An error might indicate critical problems that a reasonable application should not try to catch, while an exception might indicate conditions that an application should try to catch. Python has various built-in exceptions that are raised when an error occurs. Error handling increases the robustness of your code, which guards against potential failure that would cause your program to terminate disgracefully. Imagine if you have written a code which is deployed in production and still terminates abruptly due to an exception. Your client would not appreciate that, so it's better to handle the particular exception beforehand and avoid the chaos. Even if the logic of a statement or expression is correct, it may still cause an error when executed. For instance, if a user forgot a bracket or put an additional bracket in a print statement, so exceptions on the other hand are raised in a code that is correct in syntax but during runtime encountered some errors. For example, dividing two integers. If a number is divided by 0, it causes a divide by 0 exception. It is possible to raise a self-defined exception using the raise keyword. For example, x is 10. If x is greater than 9, then the program is supposed to throw an exception using raise keyword. And when you run such a code, the program comes to halt and displays our defined exception on screen, offers clues about what went wrong. Next, we have the try-catch blocks as also available in other programming languages. Python executes code following the try statement as a normal part of the program. The code that follows the except statement is the program's response to any exceptions in the preceding try clause. Now here in the try block, we call a function magic number. However, if the function is not there, the control transfers to the except block, which returns the print statement stating the magic number function was not executed. Imagine that you always had to implement some sort of action to clean up after executing your code. Python enables you to do so using the finally clause. If you successfully open a file, you should close it before the program terminates, so you place the code in the finally block. This is the flow of code execution, and here in the try block, normal code is executed. In the exception block, we can deal with exception errors. We can have multiple exception blocks in our program as well, and in the finally block, all code is executed. It does not matter if you encounter an exception somewhere in the try clause or not. Here are some built-in exceptions listed here as arithmetic error, assertion error, buffer error, environment error, import error, runtime error, type error, value error, and system error. In our next sessions, we will discuss them by practicing some of them using the Jupyter Notebook. In this lecture, we will be looking at some practical examples of the errors that can be arised during the process of writing your code. We can encounter various errors during program execution such as syntax error, indentation errors, out-of-memory errors, exceptions, and many others. Syntax errors, often called parsing errors, and they are predominantly caused when the parser detects a syntactic issue in your code. Let's take an example to understand it. Here I want to add two numbers together, and I missed the addition operator here and stored the result in C. Now, after running the code, it's a syntax error here as there is no operator between two numbers. Indentation error is similar in spirit to the syntax error and falls under it. However, specific to the only indentation related issues in this script. So let's take a quick example to understand an indentation error. For example, in a for loop, if I type the loop body unindented, it gives an indentation error. Now run the code and it shows a syntax error as I missed the mandatory indentation. Memory errors are mostly dependent on your system RAM. It can be caused due to various reasons such as using a 32-bit Python architecture and maximum memory allocation given is very low, between 2 GB to 4 GB. You are loading a very large data file or running a machine learning or deep learning model. Now moving on to the exceptions. Even if the syntax of a statement or expression is correct, it may still cause an error when executed. Python exceptions are errors that are detected during execution and are not unconditionally fatal. So if the script explicitly does not handle the exception, the program will be forced to terminate abruptly. As you can see in this example, as numbers and strings cannot be concatenated together using the plus operator, let's say we have two variables, A having a numeric value and B having a string value. We add them together and run it. And here it returns a type error as a string and operator cannot be added together using the plus operator. So there are specific features in Python to deal with exceptions and exception logic. So for that, use try except block to catch exceptions. You should specify or as precise an exception as you can. Let me show you an example of it. Now, using the example discussed earlier, an integer and a string are added, which result in a type error, but in a try block. Add an except block and pass a print statement here. Run the code. And now instead of throwing in exceptions, it prints mismatched values that you passed in your print statement of the except block. So what happened? The code in the try block is parsed and evaluated by the interpreter, and when it found an exception, the control falls to the except block. And instead of disgraceful program termination, the code in the except block is executed. You can also call built-in exception functions here and alias them. Here, type error. Type error exception is raised when two different or unrelated type of operands or objects are combined. Here I am calling type error as E and calling E in the print statement. Now run the code, and the changes in the result, the value of E is also printed along with my statement. Now let's see another example. Suppose a number is divided by 0. As a number cannot be divided by a 0, so the interpreter will raise an exception error. Here I have a built-in code snippet for you, and I am dividing a number by 0. And in the except block, I am calling the built-in exception 0 division error. So run the code, and it displays exception block got a divide by 0. The exception was division by 0. However, if you pass a non-zero number, try block is executed. Imagine you want to use user to enter a number via input. You want to ensure that the input is a number. You can use try except block for this. Here I already wrote a code script for you which takes user input, convert it into integer, and if the number happens to be non-numeric, an exception will be raised. Run the code. It asks for input. Suppose I enter A here. The exception is raised. This is not a number. Next, we have a key error. Suppose we have a dictionary which has key value pairs and you want to access a key that is not present in it. Then a key error will be raised when you try to get a value from a dictionary for a key that does not exist. Let me show you an example. Here we have a dictionary called data with two key value pairs. Run the code. If I access 3, it returns key not found 3. If I pass 2 in the print statement, the value of 2 is printed without any error. So again, I ask for 5 and it says key not found 5. Okay, suppose we forgot to define a variable and call it in our program, so it will give us a name error. Let me show you an example of it. Here we have a variable called as name, and I call it in a print statement. Run the code, the program runs smoothly as it has no syntax error or exceptions. Now suppose I pass an undefined variable answer in the print statement. Run the code and see an error is raised and handled by name error exception. You can also add an else block. If there is not any exception, then this block of code will be executed. Consider this is as a remedy or a fallback option if you expect a part of your script to produce an exception. Using the same code and introducing an else block to it, which only has a print statement, run it and see the result. Provide a name in the print statement and try and else block are executed, as we did not encounter any error in the try block. Next, pass the answer in the print statement. Now only except block is executed. If your code encounters a condition it does not know how to handle it, such as an incorrect parameter, it should raise the appropriate exception. Here is the code snippet. I used the raised keyword to raise an exception. If x is greater than 9, then this keyword helps to raise an exception. As it is a user-defined exception, depending on the value, it cannot be handled in an except block. Last but not the least, we have finally block. Use the same code of try catch we did earlier and add a final block. Now pass a print statement which states finally block. It runs even your code encounters an exception. Now run the code and finally blocks are executed. If I pass name in the print statement, the try and finally blocks are executed. So either way, the code in the final block is executed. Let me show you another example. This code snippet can be used to read the contents of a file. If a file is not present, then except block will be executed, and the finally block is run in either case, which says cleaning up irrespective of any exceptions. Now run the code, even if the exception error is encountered, but the final block is executed as well. Using a simple example and pass else block here. Now if the exception is not raised, try else and finally is executed. However, if an exception is raised, then only except and final blocks are executed. So this is how exception handling can be done in Python. It is one of the prime factors in making your code production ready and should be part of any project.